All right. Let's see, lights. There we go. All right. You know what? I'm gonna focus this camera. This one doesn't have to be weird. Video. Focus this one, and then I got to do YouTube chat. I got to get you guys up on screen. There we go. That's pretty good. It'll be a little bit out of focus over there. I don't think Willow's gonna come visit. She doesn't like when I make a lot of noise, and I think she's gonna have friends over today. She's gonna have her buddies over, the neighbors' corgis. It'll be a big little corgi party upstairs. All right, let's get YouTube chatters up on screen. Oh God, I need to sweep the floors in here. It's getting nasty. We've been doing so much troubleshooting that like all the garbage ends up on the floor. That one's there, and so now I need to open up YouTube. VOD. Open that up. I need to make a generic, like a handful of generic thumbnails for YouTube, because otherwise it's going to be, I think it's a kind of a strain on people's timelines. There we go. Hey, what's up here, Bothan? I haven't updated my emotes in a little bit. Probably do that. Oh, and then I need a Twitch chat popped out. Twitch TV, oh bother, it's my most gone to website. Internet Explorer recap. You watched a lot of porn. So much porn. So much. Oh my God. Oh my God. Pop out chat. Pop out chat. Chat seems active. What comment, you fucking stupid thing. Chat seems active. Oh, it went away. It went away. Jeez. Super active. Somebody said something. You sound different. Here, I can do this. That sometimes changes stuff. How do I sound? Do I sound normal? Might be depending on if I look down. Sometimes the audio changes a little bit. Or I can do... pretty the same. Oh, I got some soup on my finger. Hey, what's up, Hala? How you doing? How's it going? I did a little bit of work during the break to get stuff together here. You can see a subtle difference when I look down. Yeah, it's the, you know what, the trade-offs of having the lapel mic and no headphones. Cold as fuck here, can't get shit done. I like it when it's cold. I get more stuff done when it's cold. We had a couple days of rain here, and so we were on high alert that Willow would poop in the house, because she doesn't like to get her little paws cold. But I think this time she was a trooper. Let's clean this. I'm gonna clean this off so I have room to work. She was a trooper, and a trooper pooper. She went directly out to her spots to poop and pooped. So we did not have a situation this time around. No situations. Everything was nice and happy. A happy corgi is a happy household. She was being a crazy person when we were playing earlier. She'll grab her ball, and then she'll do that thing where dogs like show off the ball to you. They're like, I got a ball, look, I'm gonna crunch it a little bit in my mouth. And they're like, look at this ball. And then you're like, cool, hey, can I throw the ball for you? And they're like, no, I want you to throw the ball, but I can't give it to you. And then she would do this thing where she goes around behind me, because when I play with her, you know, you got to get low to the ground because she's a very small dog. So you get all the way low to the ground, and so I'm sitting up against a filing cabinet, and there's a little space between my back and the filing cabinet, and she uses that as a hideout. She will just shove herself between you and the filing cabinet and kind of wiggle her way in under you. It's very, very cute, and it's so weird. And then if you pet her butt, because her butt will stick out, she'll growl at you. So I just have this dog behind me, and it's just like, Err. She's a cute one. I I wish this big rainstorm was actually a snowstorm. I know everybody hates the snow but me. But it would be great to see the corgi outside in the snow. Why does this feel like it fell too low to the body? Is it just that I've got weight on the body, or is my suspension sagging? My suspension might be sagging a little bit. This is max. And there's a little bit of body clearance. And then when I put it down and there's weight on it, weight from the GPS, it's pushing it down into the... I think maybe my springs have just started to... Yeah, because there's like nothing right there. Yeah, I need to change the suspension a little bit so that it's a little bit more springy, so it doesn't fall down to the body and scrape when it's just sitting here. But that's when it's carrying something. When it doesn't have anything on it, it doesn't have the GPS there, I think it sits a little bit more cleanly. I don't know if anybody's really doing this stuff with their RC cars, are they? I looked up what RC car stuff existed around me, and it's all off-road stuff. It's like off-road RC car stuff, and it's all 1/10. Nobody does the little ones. Everybody has space around here. They've all got all this space that I don't have. Oh, we should power up the scope. Make sure that turns on. Super duper scope time. Takes forever to boot. I gotta move the fan so I don't sweat. We got our work cut out for us today. We're basically troubleshooting the audio circuit. We're gonna take it piece by piece and make sure that it's functioning properly. So we'll get it through the first set of current controlled, voltage controlled amplifiers, and then we have to get it through the second set of voltage controlled amplifiers, and then we need to think about the questions that somebody who knows what they're doing, not me, somebody who knows what they're doing would ask when they're building something like a mixer. Our challenge here is different, and I'm using a lot of parts that maybe I shouldn't, and my approach might not be as proper. I don't know, I'm plagued with the question, do I know what I'm doing? No. I looked up a couple things about mixer circuits, but the voltage controlled mixer is sort of a different animal from your typical audio mixer. What they'll tell you in modular synths, say, oh, do you want to mix a signal? 1 op amp and a bunch of 100 kilo ohm resistors will do it. That's not quite right. That's not quite right. Because like we need individual control of RL channels. So it changes the circuit diagram in my mind anyway. So I don't know, is there a better way to do this? Is there a way I could do this with fewer components? So far it's very component heavy, and that's kind of a problem with the 2U form factor. Now, can I do it in the end? I hope, but like I say, any project that's worth doing should scare you a little. I just realized I can do this. Special feature. Actually, I want the other power cable for that. If I can fit this one through. Yeah, it fits. I want this one because of the orientation of the tab. And then if I use... This one goes to here, and then this one. Well, it's an unfortunate placement of the power thing. If I were actually planning this properly, the power thing should be at the bottom, not up at the top like it is. The little power distribution, what's it that I kind of put into this? But it has piggyback power. There we go, it gets it out of the way. Can I pinch the corner? Nah. Yeah, so I realized that this circuit board was just the right size to shove onto the Eurorack stuff. So that immensely organizes me. Hey, what's up, Gonad? How you doing? Chat seems active. Consider, God, shut the fuck up. Shut up. Shut up with this. It keeps popping up. I hate it. I think I could have told it the very first time to never show it to me again, but I didn't know it would come up so frequently. YouTube. All right, we're all set. Did Twitch break the page layout? I haven't opened up proper Twitch yet today. I can just check with my normal. Oh my god, it's so many. Your recap, close. Your recap, close. Share your plus program, close. Started muted. Layout seems okay. There's an FFZ fix. Oh, maybe that's already active on mine, because yeah, mine's just traditional Twitch layout. Everything seems okay. I thought I had blocked too many page elements and ruined it again. Oh man, the amount of stuff that you got to block these days. I'm like barely allowed to be on Reddit anymore without an account. My Reddit account got hacked, and then I notified them that I couldn't get into my account, and then they just banned the account. They didn't give me access to it again. So I probably need to make a new account, but I've gotten used to scrolling without having an account and not losing all of my sanity and time to a social media application. So I'm happily browsing without an account, but with the Reddit enhancement suite, that keeps it looking like the older versions of Reddit, where you don't have that social media scroll, you have just headlines that you scroll through. That broke night mode, and it broke the random subreddit button. So it's just been an awful experience. And I refuse to scroll it in its sort of like new layout, the new soft layout with all the soft edges and infinite scrolling cell phone shit. Yesterday, the stream titles were above the player. That's like when YouTube tries to go into theater or into non-theater mode every time I open it. It keeps changing my settings back. YouTube also does not listen to me anymore. If I put it into auto quality settings, it'll bounce back into auto quality settings and make everything 360p. Then, when I activate my VPN, it simply does not load. It gives me this stupid fucking Fedora snoo that sort of is winking at you and makes me clench my fist. And it's like, sorry, bucko, you're not allowed to browse from a VPN. We have to track every piece of data, or else. Can't be anonymous. It's still on top. Ooh, disable top texting with FFC installed. Go to experiments. Type in the code. Blah, blah, blah. And then your chat seems kind of busy right now. Do you want to... How do I'm turning this thing off right now. Never, 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 never. Oh, God. It's going to be in, like, the weird settings, isn't it? Hold on. I'm going to go back over here. Is there a notifications? Ads, bits and cheering, community subscriptions, other revenue. This one's just a little money bag. Bounty board? Hell no. Broadcast manager. That's what I was just looking at. Twitch alerts. Fully customizable, blah, blah, blah. This is, by the way, this is what I'm browsing right now, are products that they're advertising to their streamers. So, like, the same kind of shit that they would be advertising to you guys, it's just specifically for streamers. Ugh. Goal alerts for bits. Randomize alerts. What? Randomize allows you to randomly play an alert when you have multiple alert variants of the same condition. Huh? Oh boy. Field mode, September, channel points alerts, user alerts. What the fuck? Just, where do I turn this thing off? Oh my god. What the fuck? What am I looking at here? This is like API level shit. Where's chat activity? Followers, subscriptions, gifted bits, raids, charity, hype trains, third-party integrators, goals, channel points. None of this is chat activity. I guess this is just a way to have stuff in the, like, instead of using OBS to do this, this is a direct API kind of deal, and you get stupid shit on the screen for it, which I have not had the heart to turn off. I don't know how to do that. All right, I'm sitting down. We'll go back to my normal view. I'm live. Holy shit. Oh god. Oh god. Oh, I'm live. Oh no. How's that? How are all of the one person watching me? How is the one person watching me doing? How are you? Singular entity that is watching me. Every time I sit down at this bench, I'm reminded of this pile of synthesizer parts that are sitting in front of me. I really need to get the bins out and organize those. And what I'm looking for right now is the variable resistor. Oh, I put it in the cabinet. That's right. There it is, right in front. People are starting to cubize their cabinets, and I'm very tempted to do that to this one. This is going too chill. The music's too chill. Take it over to here. Zoltan battle. How can that be chill? It somehow is chill. It's somehow chill. Open chill music playlist. Play the music. It's chill. So now that it's dried off, we had 3 days of rain, and now it's dry. Hopefully I can get a top speed for the RC car. I was really hoping to get a big number. Oh, where's my mouse? There it is. Twitch wants to train the AI with multiple clips of popular moments. Do you think they'll be able to make the ultimate streamer? And how degenerate do you think the ultimate streamer is going to be? We've done it. We've distilled the essence of streamer, and we've put it into this AI brain, and it immediately just starts humping the table. I mean, there are some brain dead streamers out there. There is just some heady brain death, like the absence of intelligence. I don't know how they get views. That's not my cup of tea. Have another one. Have a cup of tea. It all starts with a hot tub. Wait, no. We got that shit going way before the hot tubs. The hot tubs was just another meta. I actually don't know what the current meta is, because I'm not a pervert. There we go. Now it's got its little legs. It came with these absolutely tiny standoffs. Oh, now I have an extra one. This is going to be completely baffling to me in the screw bin when there's uneven numbers of stuff. And I'll find this one little standoff and be like, wow, that's really cool, and I need it for this project. I'll only have one. I don't even want to think about what, the ultimate AI? We've done it. We've made the ultimate streamer. Just it's a bunch of chemistry scientists in a lab, and they've got like this purple liquid, and they're like, this is it, this streamer distillate. One of them drinks it and fucking dies. on the spot, just dead. It was too powerful, too stupid. The kick brain rot. Kick brain rot is something else, isn't it? I thought things could be brain rotty. You know, we know YouTube poop here, right? We know YouTube poop. We thought that would be the height of degeneracy and brain rot. And then TikTok proved us all wrong. It made fools of us all. Only knew it from YouTube, and I'm happy I never went to Kick. Yeah, I've never been to Kick intentionally. Well, Kick is more where all the racists go, right? That's where all the banned Twitch people go. I don't know about the Kick brain rot. I thought I confused Kick with TikTok there for a minute, though I don't know if there's a huge difference between the two in terms of communities, but that was my moment of brain rot. All right, whatever happened over here needs to unhappen. I need to undo whatever the heck happened here. Because all this stuff exploded. And it may not stand out to you, the casual viewer of Oh Bother, but when things aren't exactly the right way around, my eye twitches. This music is supposedly here. It's a full FTL soundtrack. So there should be FTL music, pleasant chill out FTL music in the background, but I don't, FTL chills out a lot, and so the music may not even be slightly. These are all 7400 series Logic chips, by the way. This is a project waiting to happen. Possibly a drum machine. 7400 series Logic drum machine would be a righteous little endeavor for us to go down. Uh-oh, here's a piece of labeling that's coming off of one of these. That's not good. Probably the transistors. I need to put glue behind that, or double-sided. I have double-sided tape that would do the job. I'll have to find it, but that's all part of getting everything back together over here. Here's my hot ass Cougar. I have a hot ass Cougar right here. It's all taken apart because I was gonna make. What was I gonna do? I was gonna make something for my friend with it, and so I took it apart to get to like measure. And so I don't have a 3D scanner, so I wasn't really able to get anywhere with it. And he just gave me the whole thing. He's just, here, you can have the whole thing. I don't want anything to do with it anymore. He became a dad. Hate it when that happens. I don't game anymore. I'm a dad. What are you talking about? And then in a couple months, or maybe, well, no, it's going to be half a century later, he'll come back and be like, we should hang out more. His sort of last-ditch effort to regain non-dadhood. I get that a lot in my life because I'm the available one. There we go. Nice and neat. It's back up there. We don't need space up there. And then bridge it up top. There we go. Yeah, perfect. Just another platform to fall on me when I start organizing again. We'll put this up here too, but in kind of an annoying way that I have to like disassemble everything if I try to get stuff out of there. All right. That's a little better. Clears up our desk a bit more. Every inch is hard fought on this desk. We've got to suffer and struggle in order to clean it up. One thing I have to check. Okay, yeah, stripe to stripe. Got to make sure to get that right because we haven't been using diodes in our designs. The diodes can really save your bacon if you're willy-nilly wiring up a bunch of power supplies. Regain the desk. I'm kind of, I'm pretty happy with the way that this is turning out. This is the signal tester, but it's not the fully fledged one. I can't measure anything with this, so I still have to use the oscilloscope. I took the power supply out of the equation, which gives us a little bit more freedom to work on things. These need to find their way into some kind of a container. Same with the buttons. I don't know what containers I need for all of this stuff. but they do need to find their way to a container. They're going in the container zone over here. Same with screens. I need to find a container for screens. Probably need to empty out a couple old projects from those sewing bins. I think that would be the best way to store it. So let's select a project that is never going to come to fruition. This is the death of a project. 3D printer parts, including corner cubes that I didn't know. Oh, we could have matched the corner cubes. Son of a bitch. Let's do that right now. Finally gain the look back. Oh, I only have 2. This is burn the sub stuff, so I think I want to preserve this bin. But for whatever reason, I've got corner cubes here. We need 2 more. Let me just at least put these with the Maker Beam parts. These are hard to get into. Not these. No. There we go. Oh, wait a minute. Oh, we can finally color match. I know it gives it a little bit of a look, but the brushed aluminum and mixing with the black anodization, it bugs me. It bugs me. Oh God, why is this thing? This thing's like a dog hair catcher. Okay, so there's my one complaint about the iFixit bits kit. This has been a 10 out of 10 bits kit. I like everything about it. Maybe the shape of the screwdriver could probably be adjusted a little bit, but for the most part, like, the bits are the right sizes and fitment. It's been boiled down to its component parts. These are the only ones that you'll ever need. The bigger kit kind of goes to waste. I have it in my tool bin. I only use it occasionally, like when I have a home project, like I need to screw something into the wall. With the electronics work I do, this has been perfect. Yeah, it's just like nothing wasted, nothing excess. The one complaint that I have that it doesn't kill anything. It doesn't kill the deal here, but it's not a deal breaker. That's what I was looking for. The one complaint that I have about the iFixit kit is that it catches dog hair really well. And there's a bunch of dog hair that's in these bits. It works like a comb. And even though it's not in contact with my dog, the ambient air current in here is enough to put many dog hairs into this thing. And I don't close it in between using it. So I probably should do that. Hey, what's up, Commander Kellogg's? How you doing? How you doing? B-O-O-N. How you doing? Hadoom. Let's see. Let's get a little hex guy. This one. No. This one. Yes. Let's do this. Let's just put it on this. We can put this together. And then this is there. Oh, I think the neighbor's corgis are showing up. Willow's going to play with her friends. And then we... I gotta be far away to do this. Okay, I can't. That's gonna drive me nuts. The Wiggler. How's things going? I'm doing okay. Could have slept more, but doing good. We've had 3 days of rain here, and it finally broke up today. Clear skies, everything's drying off. Much needed rain, by the way. But rain is a bit of a stress moment for us here because Willow does not like to get her paws wet. And as such, when she goes out on walks, she does not really appreciate going into the areas that she would normally poop. And so during these trying times, Willow sometimes, and this is only in the recent past, will poop indoors, which is not where she should poop. What is going on? I screwed this into the thing, and now it's not like... Oh, I might have cross-threaded it. Why is it grabbing the screw so hard? I was a little too hasty, and I think I just cross-threaded this. Where did the... What in the... Sam Hill? This. Ah, there we go. Busted through the bad threads to the good ones. And then the side one. Where's my side? The side one. Oh, is my hair in the way? I'm very tired. Yeah, it's like, I went to a doctor's appointment recently, and they were like, do you have any, like, fatigue? And I'm like, I'm an adult. I'm always tired. Like, what are you talking about? Like, no. Like, medical fatigue. What's the difference? Where did that fastener go? I've got, like, nothing on the desk. There it is. Just blending in. Oh, that just slid right out. All right. Well, the advantage is that I can access the rails from both ends, which makes this easier to work on. Yeah, when being fatigued all the time isn't normal. I could do better. I could do better. I'm probably going to try to do better tonight. Get some good sleep. I have the blemished part of this one facing outwards. These are formerly used to hold up Burn the Subs, but Burn the Subs now has a system where I've got like a rail on the back, 2 rails on the back that fit into slots on the wall. So I can just pick it up and move it where I want. Maybe that wasn't our friends coming over. Analog jobbies? Yeah. I put them in here and they work. The range of them is a little bit annoying. Here, let me get this in. I just finish this corner here. And they don't have LEDs on them either. And the backings of them are metal. They're printed on metal. They're not illuminatable from behind. So I guess I've got to find... I got to do yellow LEDs because they have to look like little lamps. You know, if you're going to have the analog meters like this, you got to lean into the aesthetic a little bit. But yellow LEDs facing up from the bottom here, I don't know if that will come through properly. Oh, that looks so much better. That looks so much better. Oh my God. Here, we can... Oh, I can work around it. Bum, bum, bum. Bum, 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 bum. Could print a front panel to add LEDs around them. I don't like the idea of syncing them though, because they look good from the side. Maybe. Because yeah, then you would just put lights into the periphery. What I don't want to do is accidentally cause a huge shadow to be cast by the element, by the pointing jobby, the thingy wingy. I don't. Ugh. Where did the other cleat go? Is it still on this? Am I holding it? Did I eat it? What happened to it? Bum, bum, bum. Bum, bum, bum. Paging, little metal cleat. Oh, here it is. No, that's not it. What the? I don't understand. Today is really baffling me. Like, I don't have enough stuff to lose things with the regularity that I am. I don't have enough things. The desk is moderately clean in the area that I'm working, except for all the wires that I put to the side. Maybe I could clean those up, but my ability to lose things has, like... What the... Huh? Not on here? No. A little bit. I wonder if that could fit. I mean, people have done that. They've got little synthesizer breadboards that you can buy. You can spend hundreds of your dollars on that kind of stuff. Or you can actually just get to work. There's some people in my life that I feel like I need to strangle and tell them to just get to frickin' work. They keep ordering cool toys to help them do the kind of stuff that we're doing, but really the path to doing it is doing it yourself and building your own little helpers. You have too many things. I don't think I have too many things. I try to justify the many things that I have. What's up, Lawn Dog? How you doing? And there are too many things on this desk right now, yes. That is a weird one. How did I lose a little... Oh, there it is. It fell inside the machine. You don't have to justify it to me. I fully support the hoarding lifestyle. I'm not hoarding. This isn't a hoard. It kind of is. I guess I have to admit that. In the traditional sense, hoarders don't take out the garbage. Oh, shit. I didn't take out the garbage today. That's gonna be a point. Maybe I'll do it tonight. Ah. Okay, hold on. We gotta get this corner cube on here. Placing my corner cube so that this thing has a more consistent look to it. Maybe it's just me, but it did bother me for a little while. Ah, Jesus. What was that noise? Oh, motion. It could be Willow's friends coming over. I keep saying that, but I think that is supposed to happen today. Our neighbors recommended the dog breeder to us where Willow came from. And our neighbor is a big fan of corgis. I mean, who isn't? But she has 2 corgis. One is from a rescue, I think, and the other one is from this dog breeder where we got Willow. So they come over here, and it's the one dog, the one from the same breeder might be her cousin. Could be even more of a relationship than that, but we just don't know. Oh, we don't chat. Oh, chat is on screen. So where's my? I don't have the dual chat. What is that called again? It was called. No, I'm trying to remember what program I used. I could always open the web pages here, and then I'd have to close a bunch of pages. Every pet needs a pal. Yeah, she's not really BFFs with them though. They're friends, but her BFF is the dog that's next door to us, which is an Irish herding dog named Millie. Those two are BFFs. Well, she's Millie's BFF. I don't know if Millie considers her to be her BFF. So she's younger than all these other dogs, so they didn't at first have the energy to tolerate Willow constantly licking their face. Now that she's grown up a little bit, they're all friends. Web pages. Which one is? Here it is. Web pages. That opens up 65 different web pages for me. Oh, Twitch wants me to log in. I'm not going to be doing that. Not while streaming. Hell no. But I am logged in on the other windows. Okay, there's our dual chat. Now I can see y'all. Oh God, did all my credentials must have expired. This is why we don't close web pages. Oh, no, it's because I opened it in the wrong thing. I opened it in the non-profile. I guess that's still working though. An Irish setter named Chunky. I love names like that for dogs, where it's just like an adjective, or you have like a food word or something. You just name the dog. That's Brisket over there. Brisket is actually a really good dog name. Wait a minute. I just came up with a really good dog name. And then you get to roam around in the woods shouting Brisket. And people go, oh my God, you lost your dog? And you're like, nah, I just like Brisket. You get arrested. It's a big mess. Okay, so you guys just saw me undo 2 screws right here, and then everything fell forward, and now there's no screws here. I think they fell back into the machine. Where there's a pile of dog hair. Oh my god. What the heck? How did that get in there? What? Losing my mind. What? There's no screws. What the wait. What the Which huh? Are they still in the oh, I see. They wedged themselves into the corner cube. They wedged into the corner cube. Yeah, Brisket would be some kind of a bulldog. No, like bulldogs are like you'd call them peanuts. Oops. How did that happen? The big problem I have with Maker Beam is that they're all stainless steel, and as such, they are not magnetic. Did someone say Brisket? We're just talking about dog names. Happened again. I put the fastener on the end of the screwdriver, and then I push this through. Okay, there, that time it worked. Jeez. Yeah, if these were magnetic fasteners, putting stuff together with Maker Beam would be a whole lot easier, but instead they opted to go with stainless steel because they didn't want to have to deal with oxidization. Problem with that being, if you use a magnetic screwdriver, you get no ability to hold on to the screw. The fasteners just kind of fall, and that makes doing these operations with like the corner cubes kind of annoying. So in my computer build, I actually used steel screws, the ones that had the black oxidation all over them or whatever that stuff is, blackening, and it makes it so much easier to remove the top fence of the computer. But I had to buy a different kit in order to do that. Where did that one go? This is so frustrating. Where did it go? It's gone. It just disappeared. And if I'm trying to put the screw horizontally, it falls off at the tip of the screwdriver. Parkerization. Yes, correct. I remember now. Okay, I see it. This has been one of the more frustrating Maker Beam things. That right there was pure skill. You guys have never seen skill like that before. That was amazing. Pure skill. There we are. Something keeps setting off the front door motion alarm, and it's starting to drive me nuts. About to go burst upstairs kicking or mute it. I'm going to mute it for 2 hours. I could do that. I discovered that I could do that. They finally gave us that back. Used to be able to turn on and off the alert settings, but then they took it away and made it a paid feature. Alert snooze. Oh, I can do it for longer than that, too. Okay, well, let's snooze the alerts for the front door. Jeez. Phone's buzzing out of my pocket here. Okay, we were looking for a bin when I found all those corner cubes. We were looking for a bin. These corner cubes go back in here. And now we resume our search. This is a bin of burn the subs parts. Probably shouldn't exist, but I'm going to keep it for now because there's a DB connector in here that might be useful, as well as a water block for a Raspberry Pi. So I'm trying to find a bin where I can put all of my Funky Kong connectors. So this one's not it. That one's got RF cables in it. I want to keep that one. This is the Logitech Brio number 2, and I want to put this in an aluminum case. And we wanted to modify the aluminum case, but we discovered that my mill's axis isn't responding. It gets caught up on a number. And so the mill on that day was essentially rend of its complete power. It became partially useless. Those are DIN rail accessories. I thought I had like a blank or two. That's my old Sonicare toothbrush. I think I can let this go. I think I can let this go. We tried to make the ultimate brass polishing brush with a Sonicare toothbrush, an old Sonicare toothbrush, which would have been pretty hilarious, but it just didn't. It does this like sweeping motion, and I think that would work really well on the end of the Sonicare brush, but I don't know, it just didn't do the job that I thought it would. So it's gone. You are dead. You are dead to me, project. It would have been a funny thing to have as like a, you know, like an ultrasonic knife with the Sonicare toothbrush, but the Sonicare toothbrush specifically moves like this, which is a tough thing to make into a. I took apart a Sonicare toothbrush and was impressed by the build quality. I don't know. I found it to be fairly utilitarian. For a toothbrush, I guess it is rather nice, but it would be easy to modify and do weird things with, sure. I think I'm also going to put the buttons in here. This will just be a Eurorack nonsense bin, if I have space. Jeez, look at that. You buy Donkey Kongs by the hundreds, because you find you will need Donkey Kongs by the hundreds. And just for fun, long buttons these are basically the length where if you put your button at the end of this connector, it'll stick out by like 2 millimeters, which makes it a perfect size. A 14 millimeter button on a 10 millimeter Donkey Kong connector. I think these are 10 or 11. There we go. The Eurorack nonsense bin has been born. I don't label these, so. All right. Oh, and then I don't need to look at this. This can go somewhere else. Yeah, it's another oh that bin. Internet of Things companies try to appease their rabid investors. Could we charge for an on button? I know, it's ridiculous. So with the Ring camera, what it would do at first is I could turn on and off. I could go to the app and I could go to the thing, and then why did that it just did a motion detection. You guys heard it. It should be muted. I muted it. You guys saw me pull out my phone and go, oh, let's just do 2 hours. Go, mute. But they used to be able to turn on and off motion alerts. And then they said, oh, we're putting it behind a paywall. You have to pay for motion alerts. What? You have to pay to turn off motion alerts. I think people must have complained because they turned it back on. They turned it all back on, and now I have snooze alerts for a duration. But it's like, are you seriously going to be charging us for something like that? Oh yeah, you've got to label the label maker, of course. I have a label on the label maker that says label maker. I know where my bread is buttered. A little bit further back. Actually, circuit board bin can go back here. Headers we might need today. I think we're going to need headers today, and wires we're definitely going to need. I have 2 wire bins. Don't ask. Yeah, I mean, yeah, exactly. I'm looking for the label maker, and I'm like, where's my label maker? And I'm looking at the shelf, and I'm like, well, what is that thing? What's that fucking thing? And turns out, I read the label, and it says label maker. You go, oh, that's the label maker. Okay. And you go about your day. You know, you check. You know. You don't. You sit there and you're looking at that shelf and you're going, I don't know what that thing is. The fuck is that thing? What's that thing there? What is it? Not until you print out that label that says label maker, put it on the label maker that you know, and you go, oh, now I know. Now I know. The brain wanders when you clean stuff up. This is solder all over it. That goes out. Bonk. Okay. Getting better here. We're getting better. Never been better. This I haven't needed. This should go all the way back to the wiring stuff, which is somewhere else. Specifically got one that can do barcodes and manage and made a project that would scan them using a webcam for inventory of lab. Damn, people get serious about their inventory projects, and I don't do that. I don't operate like that. I'm one of these, like my shop is my memory palace. I kind of know where things are generally, and then things like components I have on the bins. That's sort of, you know, a separate thing. It's like I don't memorize where that stuff is. It's just the general groups of things around the shop, and I don't really need labels for everything. Some people get crazy. Sometimes they have, like, people want to search what you have in your shop and have LEDs light up where the thing is. I've seen that, and coupled with a barcode system. Absolutely mad. Yeah, but they take it even further than that. And they have their storage shelf, and then the region of the storage shelf lights up. That's crazy. You know, when I buy stuff, I don't want to necessarily have to add it into a database entry. Although I guess that would be partially useful, and then I could keep track of everything that I have. But, like, you know, when I'm forging around for ideas, I very rarely ever sit down and just like, I'm going to come up with a project to do. It's all stuff that's sort of encroaching on me, and I go, I have to do a project about that. But when I do look for, like, ideas, when I'm finding ideas, when I'm thinking about stuff, I'll take stuff out and play with it and figure it out. That's why there's an LED panel sitting right here. So specifically for chemistry glassware, I would save things like the dry weight, so I can weigh the beakers and flasks before and after an experiment and not need to look up what the tare weight was. Huh. Isn't that just part of using the scale? You just put it on. I guess in this case, it would be like, oh shit, I've poured it into the beaker already. I don't have the tare weight. Yeah. So I mean, the database would get out of the date. Yeah, get out of date. Exactly. You just forget to use it for a year. And you go, oh yeah, I have this database that I need to update, and I've got all these new parts. Why are there extra thonky con? I must have been measuring it. We have a bin for that. I have a bin for that. Oh, well, we know. Oh. Yeah. Look at that shit. Yeah. Where do these things keep coming from? I don't know what I'm going to do with this. Goes over here. I didn't get a chance to use the headphone amplifier board. That's a lot of capacitors, though. This is specifically a headphone amplifier, but damn, do they put a lot of capacitors on this thing. I guess we got plus and minus power supply over here. I guess these are like remixes? Colony ship bonus. Yeah, they just have a 1K resistor on it. Well, we're not really concerned with the headphone amplifier today. What we need to do is look at the beginning structure of our mixer. We have an idea of what we want to accomplish. I need to figure out if changing resistor values or adding a buffer amplifier are going to solve the problems that I have. Those mainly being that the voltage seems to change from my adjusting potentiometers. I guess I finally figured out why there's the trough in the middle of the solderless breadboard. And it's like, people will run out and they'll buy, you know, the audio version of the breadboard that has all of the accoutrements on the periphery that you can pull in and use. And it's like, breadboard was literally made for this kind of stuff. You don't need to buy things. That's my soup from this afternoon. Hold on. I need to get that finger clean. And then I need to moisturize. How dry are my hands? That's pretty dry. I'm gonna moisturize. Yeah, I did spicy noodles just now. I thought I was clean. The moisturizer I use smells like crap, but it's really, really effective. It's called Cutamol. Cutamol. Man, we gotta work on gaming peripheral at some point. Soup thumb. I got a soup thumb. But yeah, these, like, the little gap here is the perfect size for the potentiometers to go into. I'm not totally sure that they make great contact, but they at least don't spin when you spin the knob. So that did nothing for my thumb, did it? The moisturizer was not actually absorbed. I should probably wash my hands in warm water and then moisturize, and then my pores would take up some of the greasy shit. Hands look red. They are kind of red. Probably just because I rubbed them all over themselves. Vsauce, Michael here. Are you soup? Yeah, it's now my hands are just greasy. This is the problem with this season. Things are getting dry, and so with them bother. It's drying up out here. But in turn, my hands don't want to absorb anything either. Not much else to report on. Still no ADHD medication. HDHD medication, if you're Rob Oz. I don't know what their deal is. You know, they put in the ticket for pre-authorization, and so I get to just wait for it. I have no idea what's going to happen with that. You know, the side exiting, it might be the same distance to go from here or from... Actually, no, it's a little longer to go from back there. So I guess tying it up like that just keeps things a little bit more clear. Why does it say start soon? Haven't you started? No puppy. No puppy down in the basement. She likes to bark at the front door, and I think she doesn't like it when I'm yelling at the furniture. But moments ago, she was out there just on our side because we were playing a bunch. Is it starting yet? Yes. No. Yes. No. Hey, what's up? Nothing's working. How you doing? All right. Well, we might as well just get started. It's about time anyway. I don't have a ton to talk about it anyway. When I start saying anyway in rapid succession, you know it's become a problem. Oh, it's been a whole hour that I've been cleaning up over here. So yeah, let's get started here. There's a little bit of desk cleanup, so I had room to think. What's going on, everybody? Check it out. It's Twitch TV's Oh Bother. We are still working on an audio mixer, and specifically the way Julian has described it to me, he wants to have 4 channels where 2 of them are independently controllable as stereo channels, and then it'll have a stereo output. So we have a stereo Thonky Kong, and then we have 4 other Thonky Kongs that are inputs. They don't have to be stereo channels, but they can be organized as such, and that's how the output connector works. So that's what we're doing. We're doing Thonky Kong connectors, mono for 4, stereo for the other. the two stereo channels are independently controllable, mixable, and then there's one output that has its own separate volume control. It's important because if you want to get signals into the mix and then you don't want to blow up something that it's all outputting to. It's kind of an eclectic thing, but it would save Julian a little bit of space on his setup, and I think he's pinching at singular rack units on his setup. His setup is highly portable. It's a Eurorack system, and he uses a lot of these microscopic modules that are all the rage now. So we are taking this on because I'm in the middle of making a module testing module in order to repair Dave's Eurorack stuff. And I'm also trying to sort of get something that'll allow me to make my own things. Making a mixer is a nice little foyer into, hey, how do you make it as small as possible? So I think it was a good project at a good time that would teach us a little bit about throwing together circuits in more of a professional manner. So we've breadboarded the circuit. We got an idea of how it's going to work. We got to starting with the 3D model. We started with a 3D model of the PCB and the rack unit, the size restriction, and I realized that I needed to use different op amps in this. And the different op amps are just newer TL074. TL074 has existed for a long time. It is the most jelly bean of the audio amplifier parts that I think I've ever seen. Everyone knows them, everyone uses them. However, the TL074 did not make it past the SO era of electronics. And we're well past that now. You know, BGAs are all the thing now. But I draw the line at QFNs. QFNs are part of the enormous and smallification of everything. They are the early cell phone era, early to mid cell phone era. Actually, pre-smartphone, I would say. So in order to fit everything onto this board, I have gone into that era where there is no TL074. I've had to figure out what that part was going to be. And so we've bought an amplifier, bought 10 of them. I put them onto a little breakout board, and now we actually need to test out the entirety of our circuit to make sure that we could make a mixer. There's a lot of stuff to this. And one of the other things is, I don't know if I'm doing the best by this project. I don't know if I'm doing this the best way. The way that I decided to do all of the channel mixing is by using a component from Cool Audio, which is a company that makes cool audio products. Cool Audio has this chip that does voltage-controlled amplification. And so with that voltage control, what I can do is set one voltage to control two things simultaneously. That's sort of the justification behind having this circuit in here and why I need two of that circuit, because I've got 4 channels coming in, and then I've got a volume control independently on those mixed channels. That is a lot of real estate. Real estate is at a premium in this project. The size of the chips is what I'm referring to when I talk about real estate. So our amplifier is that little thing there. It's only a couple pixels on your screen. And the much larger voltage-controlled amplifier is that one. So that's sort of what I've been dealing with, and I think I've done it the best way, but I'm not totally sure. So we're at a stage now where we're putting the circuit down onto the proto board, we're giving it some channels, and we're going to kind of walk through and make sure that everything functions properly. Then, hold on, let me just burp. Spicy noodle burp. Blah. Okay, so then we can see what the frequency properties of this amplifier is. Now, since this is not a TL074, but it is something with similar specs that is modern, I would think that this thing can do everything a TL074 can do. There will be egg on my face if that is not the case. Why are you asking me about my A1C? I don't want to tell you what my A1C is. I told you yesterday, or last stream. That would be a waste of egg. I used the last 2 eggs in the house, actually, so there's no chance that there would be any sort of egg on my face. And if there is, I would be curious as to where you procured those eggs, because if you definitely went out at some point and bought them and brought them in here, which makes it extra crazy that you got egg on me. What was the insurance company I have to say? Why would having a particular A1C, and this is not a rant at you, by the way, this is just a rant at the medical system. Why would having a particular A1C change the type of care that your insurance company would allow in any meaningful manner. It shouldn't. If it does, it's a sad state of fucking affairs. Man, I don't know. All right. My A1C is in, I think, the low 7s. I think that's what it was last time. I don't really pay attention to it because it doesn't change from appointment to appointment. But I have a lot of weight-related issues that sort of get into that nonsense. I'm not proud of my A1C, but it is better than it used to be. Oh no, I don't think America is shrugging at all. If you're listening to the mainstream media, everybody shrugged and everyone on the internet is callous and this man was a father and a hero and no. The CEO got killed and everybody went, huh, that's funny. Like, I mean, that's my perception as internet man, is that the internet is mostly callous about this because these people are responsible for hundreds of thousands of preventable deaths. And without them, our company would save millions of dollars on healthcare. We're the only first world country, which in and of itself is kind of a problematic term, first world country that doesn't have socialized healthcare. It's like we have a fire department, we have a police department, we should have a doctor department. It's a no-brainer, but we don't have a doctor department because of permanent vacations and multi-million-dollar payouts. All right. Bada bing, bada bam, bada bingus. We got 4 channels of stuff coming in. By the way, the reason that this failed last time was that I wired up one of the grounds wrong for the amplifiers over here. So our end stage amplifiers were wired just a little bit wrong, and that caused a horrible runaway voltage thing. Oh. Why are they gatekeeping the CGM? Terrible. No, I have a doctor that will basically justify everything for me. He's very good. He doesn't, if there is a restriction like that that exists, he's like, this is fucking stupid. Here, you have chronic low levels. Like, that's all it takes. Oh, you go low all the time. You need this. What's up, Rhine Labs? How's everybody doing? Yeah, we're reaching kind of a YouTube audience, aren't we? It's nice. It's nice to see. Good to see. Good to see. Let's get a probe wire here because we're going to be probing a lot of stuff. Yeah, if you think we can probe it, we're going to probe it. Why is he laughing like that? Why is he said probe and then he just started cackling? Fucking weird. It's kind of scary, actually. I don't know if I like this place. All right, I got to get a long yellow wire. I got to color code everything. What's the point in having all of these multicolor wires if I'm not using them properly? So we have a couple different stages here to the design. The design is basically 4 channels come in. They're faded by 2. Oh, sorry, I'm burping. Oh my God. Okay, what? You did what? What did you do? I just finished 4-hour morning coffee live stream and you popped up. I tend to pop. Sometimes I lock, but mostly I pop. Okay, so 4 channels. This is, by the way, this is my little Eurorack testing setup. We have a power supply that is extensively engineered in the back, and I totally didn't build wrong at first and then had to redo and build completely differently. But we've got this little power supply with milliamp meters on the front. I've got a daisy chain power supply going through my frequency generating circuit. This is eventually going to become a full-blown, a whole ass, hold on, I'm in the middle of a sentence. Whole ass, no, get the thing, a whole ass tester that'll be able to do input and output. But for now, just so that I can do stuff, I am using just the output stage of that project. So the output stage of that project is on this PCB. I discovered that this PCB is exactly Eurorack size, where you can pinch it with screws. So now I've put all of that together, and we have the Eurorack testing setup where I can eventually test my friend's 303, but for now we're building a mixer. So this is the mixer. This is the signal generation, and this is the power supply, and then I have an attenuator if I want to put it to speakers. Hey, thanks. I appreciate you guys throwing me those. The little subscribios. Eventually, I'm going to make a thumbnail, a YouTube thumbnail for my streams. I should make 4 or 5 of them. That should be pretty quick to do, and they'll probably look like my other thumbnails. So I'll have to put together some generic, you know, like have the Eurorack, picture of Eurorack stuff, a picture of Burn the Subs, whatever project we're working on. So we begin over here with our signals going into what I guess is a voltage to current converter through a 500 ohm resistor over here. So this stage, this very beginning stage, is plus minus 10 to 12 volts, so the typical will be 10, coming into here, and the 30K just makes sure that there's 0 current behind this. It knocks the current way down. Technically, you could think of this as like a voltage divider, but this is more for like certain frequencies going through. So I don't know exactly what we're doing. I think we're going voltage across 30K, and we're getting a current. Either way, this is what they recommend in the data sheet, so this is what we use. And also, whatever Mutable Instruments does, we do. Just because mutable designs are brilliant, and we're pretty much following in her footsteps. In her footsteps? Show feet. No, but yeah, we're following in her footsteps. I mean, for Christ's sake, this is 6 channels just because the Mutable Instruments thing is 6 channels. I could have done 8. I could have had another one of these little guys. Another one of these little guys. And then I would have had to solder a wire to the back of the Teensy. On the Teensy 4.1 rather, that's going into this one though, I wouldn't have to solder anything in addition. So I could have had 8 output channels, but I don't think 8 outs at the same time are really going to get me anything over 6, right? So most of this stuff is like tuning a VCO. You want one channel and maybe a gate. So not to get like super overcomplicated, I'm having enough trouble programming menus, but this thing is going to be the king. For now, we've got the, I don't know, Archduke that outputs 6 channels and the screen doesn't do anything. I got buttons on it just in case, but yeah. We got a long road to getting to that thing. Anyway, so yeah, dude, just datasheet circuit here with the resistors and the capacitors. We put those on the little proto boards over here. The next stage is going out of this amplifier and going into the next amplifier. But I can't just put a probe on this line right here because that's current controlled. Can I just attach a resistor to it? Can we just do like one of these? And then I could get current across I'm not sure. V equals IR and all that. But instead, what I'm going to do is we'll just hook it up to our end stage here, which is this amplifier, for some magical reason, turns the current into voltage. And you could try to explain that to me, because it's probably whatever's across the 30K, but I don't care. I'm not going to learn this stuff properly. So anyway, we'll hook up to here and see what our voltage controller is doing. I did a bunch of off-the-fly calculations. I basically dead reckoned into figuring out that in order to get negative 0.6 volts to about 3 volts, which is the operation range of that voltage input pin. They don't really go over this in the data sheet very explicitly. There's like one sentence that gives you this range, which is crazy because everybody's using this circuit for their wonderful synthesizers, and it's like, did you guys just like agree to this in a back room? Like, why am I not given this information? This is how I feel with the Twitch API. They need much better documentation over it. Anyway, I dead reckon that on a plus to minus 12 volts, if you have a 10 kilo ohm potentiometer, you have 30 above, 40 below, that gives you the range, magically, of about a half a volt to about 3 volts. So we'll put that to the test, too, when we turn this thing on in just a second here. Let's get the scope on the screen, and then I'll turn off. Let's move to channel 1, because we're not using the headphone plugs. Well, actually, I mean, we could compare to input using that, but... And then at some point, maybe we'll do that tomorrow. I got to do the box fan mod on the Rigol. The slightly slower fan is nice, but like unplugging that BNC, it's hot. It's like really quite too hot. So I think we should put a 120 millimeter Noctua behind this thing. A Hawk Tua fan. I don't like that I just said that. Okay, so we're worried about these first. And I don't have any means by which to cut off power to this stuff. So we got to power the whole system anyway. Since this is also experimental, these are both on the power supply, the monitored power supply. Yeah, that's not a good idea. We gotta put this one on the independent power supply. So that's just a matter of moving the plug from plug to plug. That one's independent, and then this one, I guess we're going around back and plugging it into the metered. This is my test rig, so we've got analog gauges, although I'm not a huge analog fan, don't get me wrong. But we've got analog monitoring of current, so that if we have a current runaway situation, we won't be in trouble. We'll be able to see it. Oh yeah, no worries. Good seeing you. Thanks for chatting. YouTube can get kind of quiet. It's nice to have people talking in there. And especially as a creator, I understand, running away. You're like, all right, that's enough attention. I'm done. I'm out. Yeah, they call him the adjuster. I mean, it's like I can't help but laugh at that whole situation. You're talking to a type 1 diabetic. How much money have I shoveled into that fucking healthcare system? I'm sick of it. I have no remorse for my fellow man in that regard, especially when it's a CEO that's making billions of dollars off of my hard-earned cash. And the press doesn't understand because they're a bunch of millionaires. These newscasters are already, why would somebody do this? Why don't they just pay for their healthcare? Bonkers. All right, let's get this thing turned on. So we plug it into USB-C, because I gave myself the option. USB-C has a 15 volts. Right to repair stuff. Oh, that's cool. I'll have to check that out sometime. Yeah, we occasionally we take stuff apart. We used to have Teardown Fridays where I would take apart something like a game controller and check that out. But I ran out of gaming hardware because I'm not rich. I don't have sponsors. All right, so let's turn this thing on and make sure we don't have another runaway current situation. Boop. Nope. We see almost nothing happen. These circuits are not power hungry. Remember, we're just moving voltages around. We're not doing anything super taxing on these systems. Why is there so much heat up here? What's that? What is this? Oh, that's the voltage regulator, right. The voltage regulator in this thing is tortured. I think it's up at its upper limit of current. But I gave it a little makeshift heatsink out of a piece of desoldering braid. So it really shouldn't get that hot. But I guess it's a healthy heat. There's no such thing in electronics. Do I need to water cool it? Found one of those mini water blocks. All right, so down here we got all of our circuit stuff happening. Let's get the scope up on the screen. Arm focus in. On the scope. I'm not soldering a coin to it. I know I've got pieces of brass heatsink somewhere around. I would have loved to use that. Because this is one of those temporary permanent projects, this tester. Also, when you've got desoldering braid, you have a big copper mass that you can mess around with. All right, so here is channel 1. What? We don't get feedback anymore? Turn off channel 2. Channel 1 we've got on plus minus 10 volts. Make sure that the trigger's on the right one. Trigger's on channel 1. And we've got our output signals over here. Why is there no ass behind this? That should be a big sine wave. It is a small sine wave. What about you? Are they... Oh, X10. Boop. There we go. There's our buddy boy. All tuned up and fun. Yeah. Focus the camera, you stupid streamer. What the hell is this guy's problem? He can't even focus. His lens is all messed up. It's disgusting. Can't watch this. I gotta wipe your face, chat. I gotta wipe. Okay, there you go. Okay, so we've got our different wave types here coming in at 10 volts, peak to peak. And they've been tuned up because I have the ability to tune them up. That's what all these potentiometers are on this upper piece here. Actually, this is a better view like this. I gotta give you guys a good view of all this stuff. Worked hard on it. It's a little bit vertical. The scene here is a little bit vertical. And then finally this one. Oh. And then finally this one. Yeah, look at those. Beautiful, beautiful. So I can go to the other side of this and see them coming out of here as current. As current. You see the wave? See it? You see the wave? It's current. It's current. You can see the current flow across the. No, you can't see anything. So what we need to do is, once it's through its first stage, we'll take the output from this and we'll hook it up to here where I have that other circuit. Can you get rid of the jittery edges on the square wave? I think they're just a function of the square wave generator. You can put it through stuff. I can put it through certain electronics that will get rid of that, yes, but yeah, I see every channel does that. It does a little control systems bounce. And you can devise like a resistor filter, like I think is it a capacitor because it's such a high frequency? What is that? Mend It Mark video, the manufacturer had a bogus copyright strike on? No, I didn't say. I don't know what you're talking about. I tend to stay out of the electronics channels because I end up absorbing their memes. It's a horrible state of affairs, but it's like if I'm watching a channel and they say something very funny and it's like part of the personality of the maker, I will take it on and say it. And the worst example of this is everybody using the word chooch, or keep your stick on the ice. If you enter AVE's like subreddit, everybody's trying to talk like him, and you're like, no. So I try to kind of isolate in that sense, and hopefully we can have our own personality. That's just me. That's just me against me. I wasn't prepared for just watching Mend It Mark. I don't know who that is. Yeah, I don't know who that. Remember tuning the edges with a variable capacitor that costs $10. Oscilloscope. What? I mean, these have tunes on it that actually do that tuning. So if I hook this up to the internal square wave, which is just the two terminals on the edge of my scope, we can do that right now, and we can see if it's my scope doing this. So we can get ground on this slug. This is a feature of most scopes. They have a little area that you can hook this up. And we can look at that square wave and we can see if I've tuned it properly. And it looks okay. It looks good enough. So it is a function of the sine wave generator, or sorry, the square wave generator that's making those little jumpy bits. Did this the other day. Yeah, it's just part of doing this stuff. You got to check your own device. That's actually a big part of the module testing module, is that the module testing module is going to have the plus minus 10 volts internally, and so it'll be able to evaluate itself. It'll be able to look at what this is what 10 plus 10 is, this is what minus 10 is, and it'll be able to kind of tune itself up, making it much more accurate than your typical analog or digital synthesizer stuff. I was just watching star, damn auto spell. Oh, I wasn't prepared for is I was, man, you know, swipe typing has gotten very bad this day and age. I'm a very confused person when I stream. If you guys aren't proofreading your swipe typed messages, I'm not prepared for this. this era of language that's not language, but it's close to language, language adjacent AI type of stuff. Nah, I'm just not ready for it. So we have it in current mode. If we take it over to our amplifier over here, and I guess I'll unhook this amplifier for right now. Just get that out of there. I'm going to use the flying leads, these guys, as the between stuff signal. That way we can identify it easier. Although for some of the between stuff signal, I'm using these going around. But so let's get a jumper for this signal. I'll use short ones. The ones that I just put away, yeah. Use these. So if I want to look at the signal here that's going into the current controlled amplifier, I would need to view it here using these amplifiers that are configured with the resistor and capacitor, and out comes our signal again. So there's that one. We can look at the other one here. Bada bing. Oh, what happened to you? Why have you gone weird? Oh, because it's inverting. Wait, what is this one doing then? This one was totally fine. That one's plus minus 8 volts, even though it's supposed to be 10. I'm a good repair tech, not an engineer. I learn circuit necessary for repair and then generally forget it, unless I'm doing a bunch of the same repair. I think that's all of us. I don't think a lot of engineers are, you know, well, that depends. It depends on who you're talking to. Coming up with a circuit on the fly is a lot of what we're doing today. But it's more like art and creativity than engineering. Okay, so there's our signal, right? We get it. I don't understand why this one is all messed up. What do you look like? Yeah, they're like shifted. Well, no, the positive is less. Is that a result of my output thingy? My thingy wingy? Because we are literally just looking at this output right here. No amplifiers at all. We're just coming straight out of the thing. So we've got that 30K and I guess that 500 ohm pull to ground with a weird phase on it. That's probably what's going on. So we're just putting it into this end of the circuit. So it's not being acted upon by our amplifier yet. So I guess half of it's weird. I don't understand why part of it is fine and the other part isn't good. What about this one? What if we use this other one? That looks good. Other one next to it. That looks good. Other one next to it. That looks good. Other one next to it. That looks good. What the hell? Wait. Something is wrong. I can feel it. Okay, power down. Everybody power down. We might do soldering. Oh, I could have been going in backwards? No, that's not right. Even with schematics, you probably would not be able to figure out how to repair. Man, that's like the 808, the 303 rather. Even with the schematics, I'm like, I don't know what this circuit does. Like, what is it supposed to be doing? I need notes. I just switched scenes by accident. I'm trying to look at the RCs that I put in place here. I think one of these might have an inconsistency, which is why we were getting weird readings from it. That's not it. All the way over here. So these are that RC circuit, and they're just stacked on top of one another. Why would one of them be trending towards positive or negative in a weird way? Oh, that's why. No, because that one gets ground from over here. Pin 4. Let's check the pin out. This is the confusing stuff where I wire up everything wrong. So that would be pinouts, and that's in this window here. That's the 884062. And so we're viewing down from the top, and we've got pin 4 and pin 9 go to plus, and plus goes to ground. 808 kick drum, make the girly girls get dumb. Yeah, that 808's good. We used to have one. I used to have all this legendary musical equipment, but it's gone. It's gone the way of old friends who have gone somewhere. I had a wonderful sampler that used an old SCSI drive that would be able to do the do-do-do-do-do. Like it would be able to pitch the sample on a keyboard. Oh, man, we had an 808. We had a 505. It's all gone. I don't know where any of it ended up. Non-serious musicians that aren't in it for the long haul. I have music in my heart, motherfucker. So 4 and 9 are the ones that we want to connect to ground, because that's what the op amp references when it looks at whatever's coming in. So it's referencing it to ground. Pins 4 is pin 9 going to the top rail, which in this case is ground, because it's plus 12, ground, ground, minus 12, and then the second board is just a repeat of the first. Each board is independent. I could crack them apart if I wanted to. So in that case, minus 12 goes into pin 10. In this case, V minus. Plus 12 goes into pin 3, which is, again, V plus. And then pin 4 is in B minus. Pin 4 goes to that ground. So it might just be a matter of the grounds sharing weird across the two amps, but one of them has a strange offset that looks to me like it's not actually at ground. It seems to me like it has some kind of a bias to it. I don't know why that would be, though, because we've got capacitors on the power input and all my stuff is working properly. It's just very strange that one of them is offset by a little bit. Let's test that again and see if it wasn't just a matter of having the amplifier pushed in. I gotta get this co-witness. There we go. Yes, sir, Mix-a-Lot. Good old Mix-a-Lot. I'm gonna burp. I burped. It's all pretty straightforward. I don't know why I keep going back to the Bulldog noodles. Why do I keep eating this stuff, chat? What the hell's wrong with me? There's a song that I have not been able to find, and it's like, I love my something something. Akai? I love my something, like 303, 808, 909? And it's like a cool song, but it was like a little bit more indie, and I think it's kind of fallen through the cracks. I was not able to find the song. It's something about the Akai sample drum thingy. All right, turn it back on. Burp. We get signal? No, we don't get signal. Okay. Well, this is the output. The output goes on which pin? Out B and C are pins 6 and 7. So 6 and 7 there, and then from the outside, boom, there is our square wave. Look at this square wave. I said, look at that square wave. Okay, so square wave there. That's this channel. And we go and we look at its buddy over here. That's offset weirdly. Why are set off? Why are offset? Oh, is it control port? No. Yeah, it's like that one offsets it weird. But when we jump over to this other amplifier, it's fine. I'm 48. I show my age. Look, I have an older brother, so I know I'm a bridge between the old millennial and the Gen X. Why are you weird? Explain yourself. Let's move this over to an empty channel, because I'm feeling like this chip is influencing it. I'm feeling like that might be the case. Well, no, it's not it's not that, because we've jumped over from one amplifier to the others. They're acting different. That was mostly unplugged. Let's go back over here as I spin the wires around a bit more. Why are you like this? So 7 and 8 are out C and in C minus. out C and in C minus, and they are pins 7 and 8, out C and C minus, and pin 9 is C's reference to ground. So what if I took a pair of tweezers and I poked it in your freaking eye? Okay, let's hold on. Whoa. Whoa. Oh my god, now it doesn't reference anything. No, where did it go? I organized for this. There it is. Pinch them a little bit. Our error is a negative offset. We've got an, I don't think these invert. I don't think they do. Let's compare a good signal. Let me go back to the other one. Go back to the other one, and then I can take channel 2, channel 1, channel 2. Channel 1, channel 2. Let's get that to the right size. That's what we're dealing with. Nice waveform here. What's up, Miguel? Ooh, okay, and then I'll read your messages in just a sec. Try to keep up with the chat, but I can't have a personal conversation. I got work to do. Funny, I worked at a TV shop that had a contract with an arcade. Did CRT repairs. It was a cool way to learn. That's cool. The only CRT story that I've got has to do with my old professor for control systems, and he worked at a CRT factory. Oh, is that the dumb? That's the dumb channel. These are the ones that actually. Whoa! And he was talking about how they would come off the factory line and could potentially explode because they were huge, hot vacuum containers, vacuum chambers. So we are, in fact, inverting, which is good news because, well, no, that's bad news because then we need another stage of amplifiers to flip it back. Then again, we are not, wait a minute, we're only going through one op amp here. The question is, do these invert? Okay, so now we have to actually control one of them. The only thing is, like, this doesn't answer my question of why this op amp is all effed up. Maybe it has to do with the solder on the top there. Let's solder it a little bit. Let me turn off power, get the iron out, put the big tip on before I turn it on. We'll touch up on that solder and see if it does anything. I need to buy more soldering iron tips. I need to go on a shopping spree. I guess you can do that through Amazon, luckily, with the Pace soldering station. So you just hop on and shop till I drop. This needs to move over here. There we go. Now we're in a slightly better spot. I'm starting to think it might be the solder right here that's doing this to me, but it's weird. It's like an offset as if my ground had moved, which would mean, I mean, like the solder on these pins or these pins. Pin 9. This one right here. Looks like it's soldered. I guess I'll go over that one a little bit. Make sure it's got a good connection. But it's just the one op amp that's having weird problems. Is this thing on? No, now it's on. Nah, better than that. Like, if something was wrong with the positive or the negative input or the positive input, it would be something that would be systemic. It would hit the whole thing. And then if it's just the problem with the 1 amp, it may mean that some of these pins are having troubles. It doesn't really look like that. It's like a partial, it's like an offset issue. So maybe it's the solder joints here, although it's not really looking like it is. I guess I can swap these two and see if it still happens. Let's check now and see if we got an issue. Then going to there, from here. Oh, that looks correct. Turn off 2 just because it's distracting. Oh, it's not correct. No, wait. Yeah, from 5 to -10. What's going on there? It's like a 5-volt influence is happening on this thing. All right, so turn it off. Take these out. Swap the 2 here. They don't really get along. Take our signal, put it in to this one, and out this one. Turn it on. It's still offset, so it's something in the chip. So swap out the chip for another chip. Luckily, I got a couple. Still offset. It's something in these. There's something weird going on with these. Why? Wait a minute. No, why? What? Wait, what? That doesn't make any sense. I swap out the chips, I still get the error. I swap out the resistors, I still get the error. But if I swap amps, I don't get the error anymore. Huh? Are they... Is amplifier A, B, C, and D different? They're the same. They're the same. There's no difference. Dual and quad JFET input amplifiers with industry-leading performance. They offer low power, offset voltage, drift, ultra-low bias, B-grade SOIC, features typical low offset voltage of 0.5 millivolt. 80A 4062 family is ideal for blah, 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 blah. There's nothing about it, like, there's no difference in the amps. Amp A, B, C, and D are comically given different specifications. Why would what would then be causing why would it do the same thing wrong? It's got to be my circuit somewhere, right? The fact that ground has to go this distance, maybe? But that's only on the 1 amp. That's only on amp B. That would be a whole thing problem. Well, this one already is drifted a little bit. It's a little bit less than it was before, so I don't know what the heck's going on there. This was not an error that was supposed to really happen. Connection on the breadboard. Maybe. Oops, they're the wrong way around. Huh? I don't see any difference in the signal. It's mad. It's crazy. Like, this is as if a positive or a -5 volt signals come in here from somewhere. And offset. Because we're at -12. It's so strange. And it's only affecting this amplifier, not the other ones. But it's also swapping this out, I get the same effect. This is a pretty stable signal. Just bonkers. I don't understand what's going on there. All right. Anyway, we weren't supposed to get caught up on that. I was supposed to then go and take these signals and take a look at them. These are from the potentiometers, and it should go from, okay, so the pots aren't making good contact. I need to cut these a little bit shorter than they are. These need a little cut. Cut. They're not, the leads aren't going fully into the breadboard. They're a little shorter. Actually, I could just bend them. Will I get a consistent bend? Probably not. Nah, let me just cut them. But I want a little bit of it to poke out so that I can get into this trough here. There we go. So negative 100 millivolts up to 2.8. And I guess I could bring in other potentiometers to tune that better. But for our purposes right now, this is fine for testing. Chips looking a little hot. They're not bad. It's the relative heat thing that the lepton brings to the table. In terms of relative heat, they're not that hot. Or no, in terms of absolute heat, they're not that hot. In terms of relative heat, they look like they're on fire. But that's just because the thermal imager is a drama queen. All right, so with the leads cut, these now fit in the breadboard just fine. And I get my swing of voltages that I'll be able to control these amplifiers. So if we go into 1 amp, we'll take one signal here and go into 1 amp. Each of these actually already has a signal going into it. So I can take my pot signal and I can go into one of them. So I'll take that first amplifier, the one that was frustrating us, and I'll take the output from that, which is ganged up with its buddy, and I'll put that into the good output here. We measure it over here. We get signal, and it's clipping. Ah, what just happened? Something made a noise, and then everything stopped working. Wait a minute. This isn't fair. Oh, this thing popped out. Oh, these are so frustrating. Potentiometers are incredibly frustrating when you're on a setup like this. What happened? What happened? Oh, my resistor capacitor popped off. All the way over here. There we go. Now we're back. Jeez. This one, his hands are the same. Yeah. When my hand comes in, everything kind of fades out. These stay at like a 80 degree, 90 degree temperature. They do generate heat. I mean, there's a lot of heat that's being generated in this whole setup, but yeah, my moderator originally got me the thermal imager because he was frustrated with me constantly poking the electronics and burning myself. But that's totally part of this hobby. You're going to poke stuff and it's going to burn. This doesn't make any sense. What? I thought you was an amplifier, man. Well, what is he doing? What? Huh? 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 That ain't makes that ain't make sense. What's So double check our setup. Waves coming in, goes to the filter. That goes immediately to the channel input on pin. Let's check our pins. Yeah, the ouch test. The cool audio. So the cool audio thing, pin 2. And then it comes out pin 4. In our case, it's the lower one. So we're actually pin 10, control pin 11. Yep, that's how we are. Blue wires coming from control. This one's our output. And it's doubled up, 12 and 13, which are 2 of the outs. Should be perfectly fine for us to mix that. And yet our control voltage isn't really doing it. Well, it's constantly slipping out, which is one problem. It's a problem I have. Constantly slipping out. Back to work. Thanks for the stream. Hey, appreciate it. Thank you for chatting. So where is my voltage? So let's grab this little guy right here. Pull him over to this little guy right here. My control voltage is fucked. What's going on? What? Huh? Pull it all the way over to here and put it on this. Full swing. The potentiometer cannot handle, or sorry, the amount of current that's coming out of this thing is being altered by the input. There's a couple things that I could do for this. We could drop down a decade. We could do, instead of a 30 and a 40K, I could do a 1K potentiometer. So 1K. Let me just erase, hold on. No, not variable. Dog is barking. Blue British symbol. So if I do 3K, possibly 3.3, 0.3, 1K, and 4K, we have 8K current through an 8 kilo ohm resistor is pretty heady. So I don't know if that'll overdo it. We could try it though. Let's give it a shot and see if it'll maintain its erection for more than 4 hours. So let's turn this off. Get some of the fly leads out of here. And get another pair of female headers. And actually a new set of these. I need to find new ones. If I can do this without an additional amplifier, if I wanted it to be super duper low current, I could use those resistors and then I could have them go into a non-inverting amplifier, and I think have that voltage range just fine. Or I could invert the voltage on the amplifier and then put it into an inverting amplifier. And what it would do is it would see one voltage on one side and recreate it on the other, but harder, so that it could actually drive all the stuff that it needs to drive. I'm going to try instead dropping down a decade and using smaller resistors so that we have more current running through everything. Smaller resistors, more current. So if this is the, I mean, they've left by now, but this is the stuff that differentiates the engineers from the technicians. It's not that big of a gap. So resistor, I think I can take this without everything falling on me. Almost. Everything almost fell on me in that stack that I made earlier today. My butt hurts. Everybody stand up for a minute. All right, so I need 6 of these. I'm doing this because I've got more surface mount resistors than I have through hole. I mean, wait a minute. Could I just make the voltage and then have potentiometers running between them? And have just one set of resistors power all 3? If I just do... Well, no, because then... What if I... But, like... This and this... And then I have the 3 in between. Does that mean that the current is going to change, but not the voltages? So if I do an additional 1K here, is that going to influence its buddy? V is equal to IR. Well, let's make a circuit. Let's make the circuit then. 3.3 and a 4K. Actually, that should be smaller. This should be on the order of 2 point something or other. Because we wanted to go a little bit more negative than it's been going. In this case, I can actually make them all potentiometers. and we can tune it, and then we can look at what the resistances are. That'll be a little bit easier on all of us. But hopefully using kilo-ohm resistors means that it's going to have enough oomph in order to, you know, affect the multiple things and not be affected by multiple things. This way we get exactly the value that we want. This is still sealed? Wait a minute. What? Wait, where have I been getting these from? I have 2 kits. Instrumentation potentiometers are very nice to have. 25 turn jobbies, these blue things. We are doing audio grade, but having instrument grade is very nice. Number 18. Whoa! Is that like collectible? Can I get like $40 for it? 1K, 102s. We've only got 10 of those? Well, let's try to build up our ideal voltage adjustment suite here. And then what am I going to need? I'm going to need potentiometers that are through hole, and we'll work on this board. And they'll be 1K. Lest I have to go into a buffer, which I'm trying to avoid. It's the thing that I really want to avoid is going into a buffer. These are all 103. These are 104. These are 100Ks. I'm looking for 102, which is 10. No, that would be 10K. Yeah, we're looking for B103, the soft rock station of Philadelphia. No, that's B101. I want B102. These are all 103. These are audio, so these are going to be logarithmic control. It's 100K anyway. It's not really that useful. What about you? 100K. Here. Are these all 100K? I know there are some 10Ks in here. Or 1Ks. Some of these came from multiple values. Is everything 100K? Oh my god. 1M. A1M. Ugh, don't tell me the potentiometers are going to be the limiting factor today. 100K. I've got to have some 1Ks. M. 1M. These are all 1Ms. Sheesh. 1M. 1M. Damn it. I don't know if I've got the right pots. What are you? You're 104s, right? Did I order 101s? Maybe I didn't. Maybe I've not had them. I don't want to tune it to a 25 turn one. I think that wouldn't be very good. But if 1K is not available, I guess they don't use them very often. We're back to my other scheme of doing it with the 10K. I don't want to have the 10K in the middle of the two. I don't think that would really do it. Well, the math gets weird. These guys, like the 10 turns, I don't know if I've got 1K. Clarostat, 100K. These are like 1M. This one's 1K. That's made in the UK. How about that? This is a really nice instrumentation pot. What are these adjusting? These are adjusting. So I've got a voltage-controlled amplifier chip. Spiffing. This one's in the UK too, but it's 10K. And finally, 10K. Okay, so let's go over the circuit a little bit. Maybe you guys have some ideas that I don't. I don't know what I'm doing. Let's be honest. I don't know what the hell I'm doing in audio. I don't know why I'm here. I don't know what I've been placed on this earth to perform. I don't know why everybody's looking at me right now. I'm scared. But if we look at the plan, we have a voltage-controlled amplifier that's going to become a mixer. So we have LR channels, 2 channels, L and R, that are controlled by voltages. The voltage, in like a little footnote in the data sheet, is 3.3 volts to negative 600 millivolts. You guessed it. You guessed it exactly right. It's the very common negative 600 millivolts. This is like when somebody tells me, like asks me how long is until we get there. I tell them 7 minutes. And the reason I say 7 minutes is because it's not 10 minutes and I'm not there yet. And so I give them a very, very specific time. And 7 is the least useful number. If you have a microwave, I don't think you've ever hit the 7 key. I don't think any of you have. And if you say you have, you're just a freaking liar. You're lying to me. You are one of these people who are always in opposition to everything that I'm saying. Just for the sake of it. You should reevaluate your life and how annoying you are to me. But anyway, so 7, very weird number. 6 is right up there with that. Why would negative 600 millivolts be the control voltage? Anyway, we've got to achieve it. And so in order to get that, and in order to get a weird range of negative 6 volts to 3.3 volts, I dead reckoned some numbers. I threw some numbers in and did some calculations on minimums and maximums. And I figured out that if I had a 30 kilo ohm resistor and a 40 kilo ohm resistor on either end of plus to minus 12 volts, that a 10 kilo ohm resistor gave us just about that swing. It's very, very close. I try not to pay attention to that, but I know 5 is the morning news number. If I come downstairs and I'm having my coffee, I keep it at 5, and that way those annoying fucking ads that they put on all these TV channels nowadays don't have exactly the right size drill to get into my medulla oblongata. Otherwise, the audio is just drilly enough to get all the way in there, and I go, maybe I should buy Tampex, but no. Put it on 5, I tune it out, and pet the dog while drinking my coffee. So I've had a thought. I had a thought worm blow up in my brain, and I thought, what if I do voltage level top and bottom, and then I have individual adjusters in parallel, and then the parallel effects of resistance, I think, then step in, and I don't think this works. I don't think this works. I'm not sure. I was just thinking about whether or not I could have, like, treat this like a voltage source. Maybe we'll try it out in just a second here. But yeah, so this is what I dead reckoned in order to get plus minus 12 to go within the range of voltages. The only problem is when it gets into this thing, and if I have these two connected like this, the effects of the voltage suddenly completely changes. And the voltages that I'm getting out are totally different. So my thought is, what if I take it down a decade? And if I take it down a decade, maybe these have enough dick to get into this thing and actually get it hard. So we'll see. We're not really supplying. These are technically reference voltages, although there is an internal resistance to these, which is why maybe I need to put it to an op amp. Which is a completely ridiculous thing for a circuit like this. Why would you be like that? This seems to be entirely designed for the mixing of stuff, but it doesn't let me do dual controls. Let's look at the Cool Audio chip. What was that called again? Let's try to get a part number off of this and look at the actual, because it's from some Bush League company, we don't get an extensive data sheet on these. We only get a little bit of information. But we can look at circuits that use these and maybe circuits that parallel these together and see if other people have solved this issue. I can't see a thing. What's going on with this? Are they trying to keep it secret? V2164. There's a lot of versions of this chip. The V2164 is one of the many versions. You get bits of data, different bits of data off of different, hold on, data sheet, off of different versions. Luckily, there is Cabin Tech. Cabin Tech has all of this stuff. Cabin Tech Global, if you're in the Americas, this is a good place to order it from. It is not a cheap chip. But they have compatible replacement parts. And these all have slightly different properties and availability. I chose this one just as a roll of the dice. Is the same one that Mutable Instruments uses. Will operate over wide voltage operates, so for the baby 18 and available 16 spots CC. Okay, data sheet. Data sheet. Cool audio. 4 independent voltage controlled amplifiers in a single package. High performance range is provided very low cost per VCA, resulting in excellent value for cost. Ground reference -33 V per dB control port. B2160 is available for many applications. For performance VCAs in a single package. So that's the diagram, and then we've got all this stuff. So tell me about my inputs. Tell me about my control inputs. Maximum gain, channel separation, unity gain, bandwidth, slew rate, input bias current, plus minus 10 nanoamps. N is equal to 0, blah, 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 blah. It's only down here. We've got their basic circuit, which is what we're working on. 300 kilo ohms, 500 ohms. And again, we reference this also to Mutable Instruments, who's using very similar circuits. I should look at her control scheme, huh? I guess, I don't know if this is a good one to go to. What was it called again? Ripples, maybe? No, there's one that's a mixer. Branches? Bag of cables? Links, maybe? I'm trying to remember. Tides? No, not Tides. Tides is a generator. It was like channel 1 goes into channel 2, goes into channel 3. That might not be a good one to do, actually, to be honest. We'll try ripples. We'll see. Oh, yeah, you got to go in from over here. Oh, there's a redesign in 2020? Oh. Cool. Schematics. Oh, my God. Yeah, ripples is one thing into another thing. So you put in an input, and if you don't put in an input, it goes to the next output, et cetera, et cetera. Why did that zoom like that? That was very clunky. So what we're looking for is a voltage-controlled amplifier. And I don't, maybe this one that doesn't use one. Oh, it's clunky because it's loading weird. Okay, this one uses a different one. This one uses a different kind of voltage-controlled amplifier. Oh no, here it is. 1A, 1D, 1C. So here are the amplification stages. And the controls are FCV. So it's coming out of a buffered control voltage and the 5K pot on the feedback, but that's because we're mixing in control voltages, which I'm not doing. We don't have enough pins to have control voltages come in and control stuff. But either way, they're going into something that's buffered. Oh, here's a 10K ohm right there too. So yeah, there's 2 different controls on that. I don't know if Mutables has done anything that doesn't have control voltages going into these things. That's part and parcel of why this 4-stage amplifier is good in Eurorack stuff, is because you can have a control voltage mix with your knob, and yeah, then you get your stuff. But it has to do that through an amplifier. We're trying to avoid that because I only have so much room on this board, and especially on the design itself, it's going to have very little room. So what then? These to the side. Let me dial up a circuit with just 1 kilo ohm. I really could use those other potentiometers that I don't know where they went. I think there's more in here that I haven't observed. We could try to find another 1 kilo ohm. This is a pack, so I think one of these are 1K. Not labeled. That's 2 something or others. 5K. 5K. 20K. Ow, it's a pokey. These are pokey bits. 500K. Okay, this is not the right thing. All right, so for multiple potentiometers on the same reference, let's just put the 10Ks, these to use a little bit here, and I'll make a reference here. And I'll just have to look at what the values of the resistors are. So 3.9. Oh, because I didn't go full to 4. That's why we didn't quite get there. 3.0. Actually, let me make it out of the... I'll make it out of the blue guys. I'll make it out of the blue guys. We'll have our exact voltage references. And these are 1K? Yeah, 102. So I'm going to drop a 102. Actually, we'll test this with 1, and then we'll test it with multiple. So yeah, let me dial this back here. I can get most of this assembly out of the way, too. And then I'm going to take positive 12. Through a pot. We'll dial the potentiometer to plus 12 goes through 30K. So let's get this one to be 3K. Oh, my probes are under my light stand. They're not. There we go. I got it. I got it. I don't believe you. 48M. 102. That shouldn't be mega ohms. Oh, there we go. Hold on. I'm giving. Jeez. This is. I need my probe adapters. What do you mean, OL? Jeez. You gotta poke all the way into these things to get them to do anything. All right, 400 ohms is not quite what we want. It's close, but it's not quite it. $500 ohms, given the rate that I'm turning this thing. $590, 600. $102, 1000. This goes up to 1K. Oh, up to 1K. Yeah, that's the problem. That's the problem. Dumb. Streamer's dumb. That's the issue here. Where'd the bin of pots go? I know you're here. I can smell you. What the deuce? Where did I put the other way? Are they way down here? No, not in the stack. What the heck? Did I maybe I put them back in the drawer? Yep, they're right here. Okay, sorry. For 3 and 4K, we need 10K pots. $2K, 10K, 103. Here we go. These are the ones that we're going to see if we can create the voltage rail out of. Okay, so 4.8. Adjust that down. Sloppy machining on the nub on this one. Wonder how much money they saved. Four, 3, 2, 1, 3K. Damn it. Come on. Ah, there. Close enough. Problem is when you observe it, it changes. Okay, so that's one end. And then the other end, the one that's hooked up to minus 12 volts, is going to be 4K. Look at this. These up here. I'm just going to spread this out so that I have plenty of room to work. Any tweezers for this? Where are my tweezers? Boy, I thought I'd be cracking this whole circuit open today. These are problems that I've needed to figure out for quite a while, though, to be honest. You need to figure out how to get this to adjust multiple gates simultaneously without the voltage supply changing. And it looks like, at least from the one mutable circuit that we observed, it's through a buffer. And I really don't want to do through a buffer. What the? This bugs me about these. Something is going on with this one right here. And it may be that the clip is damaged or worn in some way. But when I try to plug this in, it fights you. There, that went in finally. So between this one and this one. And I want this one to be 4K. We're close. Flathead screws are going to drive me absolutely bonkers. All right, I gotta use my hand to stationary the screwdriver. .005. That'll do. So now with a 1K potentiometer in between these, we can do with just a couple little jumpers. Take these to 2 pins. Oh my God. This perforated board is just fighting me at every turn today. There's that. Take it over to this one. It's when the clip doesn't engage the pin and you push it in, and so it bends the pin, and then so the pin doesn't go into the clip properly anymore because it's bent. That's when I get mad. All right, so 1K right here. It's even breaking my really nice instrumentation pots. Those are like $10 each. They're not cheap. So here's our voltage output with just one potentiometer connected. And if we turn on the system, there is aggressively ground. There we get up to, what is that? 1 point something volts. What the? Negative 400 millivolts. But it's not going fully up to 12. Did I hook this up wrong? That's negative 12. Oh, I got the wrong. I think these are swapped. Ugh, why aren't you plugging in? There. Nope, that ain't right either. Nope, swap them back. Swap them back. We may have adjusted the wrong ones. Well, that's fine, because we can just take it all the way to where it should be negative 300, and I can adjust this around. Actually, that's pretty close. $400. How come that's moving and it still gives me the same? Oh, because is that V peak to peak? Oh, V max. Oops. I was like, why is it moving so much if it's not? I was looking at peak to peak by accident. So on this end, we want negative 600 millivolts. That's approximately there. And now on the other end, I want 3.3 volts. All right, so there's our full damn range adjustment. And now we have more current behind it. So technically, if I hook this up to the rest of our circuit using the jumper over here that I threw to the side, from this output going into just the one channel's input, it changes the damn voltage. What the heck? Yeah, the input has properties. Let's take a look at what they are. That would be in this, not this, this. See, they figure 8 volts and a 100 kilo ohm. Where am I getting 8 volts from? And a 0.1 off to ground. What is that doing? Configured identically, 30 kilo ohm resistor converts the input voltage to an input current for the VCA. Additionally, a 500 ohm resistor in series with a 550 PF capacitor can be added from each input to ground to ensure stable operation. The output current pin should be maintained at a virtual ground using an external amplifier. But then they're taking this, for some reason, 8-volt signal and turning it down to, what is our V in? Plus and minus 15. What the? Here they don't talk about that. 4 VCAs in a single package can be configured to create a simple 4-channel mixer. The inputs and control ports are configured the same. This is essentially what we're doing. Control ports are configured the same basic VCA. The outputs are summed into a single output amplifier. Additional VCs could be added to increase the number of mixer channels by simply summing their outputs of the output amplifier. Another possible configuration is to use a dual amplifier, such as the OP275, to create stereo 2-channel mixer with a single module. That's essentially what we're expanding on. If additional are added, the 100 PF capacitor may be increased to ensure stability of the output amplifier. That doesn't really happen. I don't think so. Which one are they talking about? 100 PF maybe need, it's like, they're just like, if you add more of our circuits, you may need to add a capacitor. Well, where? What are you talking about? Most op amps are sensitive to capacitors and their inverting inputs. The capacitance forms a pole with a feedback resistor, which reduces the high frequency phase margin. I see. Okay, well. I thought I turned off motion alerts, to be honest. I thought I turned it off for 2 hours. I guess maybe it's beyond that. Is somebody just doing laps at the front door? Is that what's going on? Motion setting. Or no, we're not going to do that. I'm going to do snooze alerts. I don't know. Give me another 2 hours. Jeez. It was nice and quiet there for a little bit, but now I've got the The lady who shall not be named barking at me. More added to the mixers, blah, 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 output capacitance, parasitic trace capacitance, add, increasing the overall output capacitance, blah, 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 blah. So that was a word on adding additional amplifiers to the circuit. Keep it parallel, blah, blah, blah. Single supply operation. This is a different thing entirely. 0 dB gain at V plus 2. That's just on creating pseudo grounds, and then no other information about mixing the inputs. But there's a very, very distinct effect on my input coming from the pin that I connected to. So I think I need to tune my ends here, my adjustable ends, and figure out whatever that's going to be. This is crazy. Because I no longer can go fully out to the 2 poles that I'm supposed to be going out to. Does that affect the actual performance of the output over here? I can't like know if we had this working perfectly before. I don't know what happened. Instead, it seems like my efforts to make this actually adjustable are just, it's just making fun of me. What is it doing here? Why is it like this? All it's doing is affecting a voltage offset? And like, okay, I have not done anything controversial here. Did I hook it up wrong? Well, I hooked the 2 outputs up to one another. They shouldn't really be affecting each other, but maybe if I pull my mixing output. Yo ho ho and a bottle of rum. Wait a minute, what's going on here? Okay, well now I just get nothing. So wait, was my signal coming from over here? But that's the wrong output. Why is the triangle wave over there? It shouldn't be over there. Wait a minute, it shouldn't be over there. Where's this? Is the triangle wave coming from over here? Oh, maybe there's more to this circuit than we... Okay, I'm ripping up any of the inter-circuit connections now. Those are now isolated from one another. So now if I plug into the output here, nope. What's my voltage level? So here, this should be on, but it's not. Okay. So double check the pinout. Jumper down right there. Audio is coming from this circuit here. So we're on this orange line. Orange line comes in at pin 10. Audio comes in on pin 10 here. So we're VCA3, and VCA3 is controlled from pin 11. And it outputs on pin 12. Output on 12. That's my output line right there. This is my control line, pin 11, input of pin 10. We come over, we go to the good amp, which is the further one. And we come out here, and the circuit is turned on, and we have our input signal. That's what the blue is. Is this amplifier dead? Is it a dead amp? Because why would I be getting a triangle signal? All right, let's switch to the next one then. We'll check this one. Output here, pin 13, control input, pin 14, input is pin 16. Sorry, 15. Aha! I found you. That might actually be the signal that we were chasing before. That one might be dead. So our output here is perfectly inverted, and we have 0 gain. I can turn it way down. We lose our trigger, but whatever. And turn it way up. That's a little bit above max, so I can actually adjust that out. So there would be our maximum, and then our minimum should be just when it's indecipherable. That goes way past where it should probably be, because there's still a little bit on that. Zoom way in. That's indecipherable. Oh, because I'm doing the wrong channel. All the way down, all the way down. Flip to the right channel. Oh yeah, look at all that noise. Noise, noise. Noise, 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 noise. That's actually pretty good, to be honest. That's like very barely past the point of twisting. So I think that's pretty well tuned for maximum up and down. That back to 10 volts. Just all the adjustment happens at the end. I may need to put logarithmic potentiometers on this thing. Of course, the logarithmic ones that I have are a totally different value. But what happens now if I put in a different amplifier? Although, what happened to this other amplifier here? Because apparently our signal, is our signal even getting through? Like, all right, let's test this here. That's a square wave, okay. So we got square there. And if we send the output stage here, no, wait, which one's the output? The adjustment stage is there. These are the 2 output stages. So I take this output stage and I put it on this adjust stage. We get nothing. Good day to you, sir. I might be mixing them up. Which one? Pin 14 and pin 11, and then 12 and 13 are the outputs. So our square wave is not getting out. Oh, but maybe I need to turn up the volume. No, I had it up. Okay, so square wave is broken. Wiggle the wires a little bit. So we do know that it is... No! Oh, dropping the screwdriver. Yeah, all the controls at the very end of the pot. I am going to need to have a logarithmic one. So there's our control voltage, and there's nothing coming out of this amp. This thing is broken. That's unfortunate. Let's test the others. So, control here. It barely reaches. Output here. Oh, that still clips. I should turn that down a little bit. I can't without my screwdriver! No! Where did it go? Oh, there it is. Around the corner. Up your butt and around the corner. All right, so this is getting kind of finicky here, huh? I guess I'm going to need bias resistors on some of these in order to adjust them properly. Because you have that, and if we match it to the input signal... Oh no, that's the messed up one. That is not the same. There we go. And these are maximum amplitude, so That just about right. Does it look like it's squishing it a little bit? Is this actually the triangle? The dog hair on the chip is causing it. Hello. Get your hair off of my electronics, god damn it. One day a week she sleeps in this room and that sets everything out. Now she's barking at the door. I do need these to kind of, I probably should put them through another amplifier just so they match up properly. But okay, so that's coming out of here and that's all well and good. If I take away the control voltage, oh, see, it's retaining that control voltage. Maybe that's what's going on with that other channel. Well, no, because I didn't. So anyway, if I put the control in here, that should be doing anything, and it's not. But if I remove this, there we go. And that one's half the amplitude. Why is there so little amplitude? Oh, because it's coming in at half the amplitude. Why are you coming in at half the amplitude? Ouch. Voltage regulator just burnt me. Should all be unique waves. But that one's all messed up. Only works when I touch ground. Still haven't solved that problem. Why are you dumb? Why are you like this? That one, that one, that one, that one. And we've got the 3K and the 15. And then if we look at them on the other side of them over here, find our wave. Can't reach it. I need a bigger jumper. Not sweater, jumper. Wee, wee, wee. Why is that one all messed up? Well, you like this? That one, this one, over here, this one, that one, over here, this one, that one. Are they both squares? I feel like I'm taking crazy pills. Is what's going on. I keep testing these. Well, these aren't converted yet. Those are the conversions. So, sine wave, triangle, sawtooth, square. Sine, triangle, sawtooth, square. Square. Sawtooth. Triangle. Sine. And these are the same amplitude. And I did flip the 1 to 10 switch. Sleeps. No, she does sleep because she ugly snores. She's out here going all the time, man. She ugly snores. So these are already being piped in and are coming out. And I guess channel 2 needs to be, or channel 1 just needs to be adjusted so that it's the same amplitude. It is the same amplitude. It's just my output is 10 volts and the end result of all of my synthesizing is 5. I guess I'm getting a 2 to 1 on this. And then the output from this is here. Much smaller amplitude than my input, which is fine. It's just above that it clips, I believe. So let's see here. If we go, let it go more positive. Get that even. Jump over to another channel that has the same exact amplitude. Yep, get that max. Jump over to a working channel. This needs a longer jumper. Need a longer jumper. No, I'll just stretch. Stretch all the way over. That one does not work. Oh, because I lost... No, just in that one I lost signal. The wire came out. That one's fine. It's still getting an input. Oh, wrong pins. Okay, there's all the way up to maximum amplitude. Okay, so then this channel seems to be broken. Maybe because it's not soldered. Let me turn everything off and I'll run solder on those pins. So this setup rig the jig has been very, very useful. It's keeping my head straight while I do this. It seems as though we're probably going to be poking at the circuit until Friday. I wanted to have a hashtag sponsored stream next stream and it be us designing this in AutoCAD, but I still don't know what I need in this circuit in order to get it to function properly. We're getting there though. This is the crucible where we boil away all of the excess circuit stuff and figure out what really makes this thing tick. Turns out this one is just broken amplifier, but I wanted to have the whole circuit running, not just part of it. Other than that, I don't really see any other issues here. So let's take a look at that one again. Power on. So why is there a latent waveform? I guess it just doesn't know. Yeah, it doesn't have any, it's a latent voltage on this pin. Hello, Square Wave. Where have you been? Okay, so we've got Square Wave back. So I think just hitting a little solder on that pin is what it took. Hope the rest of these are up to stuff. I've had a lot of cold solder joints lately. I don't know what's going on with that. All right, so stepping through the circuit, the next thing that I want to do is set up another control so that we are controlling the two things at once. And we will do that with just a yumper. We're going to see if our 1 kilo ohm thingy-wingy is doing what we think it should. 1 kilo ohm higher current adjustment, we can think of it as. And so that requires me to tie 2 inputs together across 4 pins. That would be a jumper that I probably don't have. Take a look for it. You guys have been very patient with me over the course of doing this stuff. And we really should pick up kind of a new project that people can follow along with. It's been a long time in the making, this stuff that I'm working on. Really, I should do it like this. And pull these up a little bit more. Let me get these out of the way. Here to here. I need to bend those down a little bit. All right. So tie the 2 control ports together. Let's take a look at our waveform again. Boom. There's our square wave. I can drop the control port here. Okay, I still get max amplitude. So is it the 1K, 10K scheme that's giving me this, or is it the well, it could be the crappiness of my potentiometers. That could be part of what the problem was. I don't know if singular K, 10K is what did it, but let's actually pull back in our values and see if they're affected in that way. So we need to, I'll turn it off just to be nice. turn it off just to be nice, and then we'll hook up our other control scheme and see if that's what's affecting. So 3.3K to positive power. Actually, I'll build it out here because there's a little bit more space. All kinds of stuff flying in the way. $3.3K to positive. And then potentiometer. Like so. And then we need the 4K going to negative. Actually, I should do this with 100K pots. You get two 100Ks, and we'll hook that up. Oh, and then I need a gray wire. I ran out of grays. I'm out of gray. Plus 12. Yeah, it needs much shorter. Needs something like orange. Miguel Oz, what you doing? I guess I don't have Santa, please. Happy holidays. Hey, happy holidays to you as well. And to you. And to you. So what are we doing? We're doing 30-ish and 40-ish. So that means 50-ish is what I probably need. Although 100 if I want to have a huge range. We could do 50. 50K. That gives me a good amount of adjusting. A good amount of nothing. Come on. There we go. And then this one, same way, but on the other one. The potentiometers, one goes up, one goes down. And then I can measure using the probe, and we can get our upper and lower limits established. Power on. So there's our lower that needs a ton of adjusting. Where's my screwdriver again? Oh, it's right here. And that has to be 600 millivolts. So this is plus 12. This one's minus 12. Oh, and we have to be all the way to the left here. Or wait, all the way to the lower adjustment. I don't know where that is. It would be towards negative is on... Oh, I've got them backwards, so I'll turn this one around. I can't see what I'm doing. Hey, Mahalo, how's it going? Yeah, people are approaching their vacation time, huh? So minus 12 on this one. It's a little bit backwards. It's just the way I've got this thing set up. Minus 12. And then on this one, we'll have plus 12, which is the top of this thing here. Come on. Go to your home. Put me in a home. What the? Okay, it's all cockeyed. Hold on. That one there. Oh, I see. The wire's just a little bit long. I'll just do this. Just for the sake of getting it done. Of course, then this one doesn't plug in and it gets all weird. Oh my God. I hate this. This breadboard is so bad. I don't know what the hell. Okay, all right. Easy does it. Easy does it. Green will get you there. Green will get you. Easy does it. There we go. Okay. So now we're at the upper limit, and well, our adjustment appears meaningless. So take this one down. What direction? Oh. Yeah, we'll do it. I'll do it by ohms. I'll do it by ohms. So one needs to be 30, the other needs to be 40. I'm going to do this with a multimeter real quick, just so we can get this test done. And I can definitively, well, I can finally know how to mix the control inputs. So I want 30K to positive. 28, it's close. Hey, you guys can't see it. I was looking up there for the number. I'm like, where's the number? 29. 30. 3, 2, 1. 30. All right. This one, 40. Oh, I see. They weren't connecting before. I see. Ah, 38. Okay, 30 and 40. But we need to make sure that they are set up correctly on the pins because these skip one. So if I'm coming in there, it needs to be this one, and this one. So we're off by one pin. So I actually need to take this, I need to move it to here and move the power pin over one as well, which I can't do. I need to move the other one. This stupid gap. It's so annoying. That one has to be there. This one has to move in on it, which it kind of can't do. No, there needs to be one pin in between them. Yeah, so wait, that one's there. This one is where? 7 there is everywhere. Oh, okay, so that is connected properly. Okay, that is correct. We have this wired correct. What? No, we don't. Power needs to move in one. Everybody needs to move up one pin. Up one pin. Can't see what I'm doing. One pin. One pin. There we go. Okay. All right. So now, they just moved the wrong one. Yeah, I moved the wrong one. This is the wrong one. This is wrong. The wrong thing moved. This is not. This is supposed to go down here. That's fine. This is the one that I need to move. I'm losing my mind. I'm losing my mind. There we go. Okay. Now I can put the potentiometer down there. 10K. Any of them? There it is. 1, 2, 3. Like that. And now we should have negative 600 millivolts to positive 3 volts once I turn this thing on. Return on power. Channel 1, channel 1, 1, 1, 1. Why am I not getting anything? Oh, I'm on the wrong pin. Burp. More pot than Cheech and Chong. He's more pot than man. Somebody call Snoop. He's the only one that can approach the reactor core. We're bathing in potentiometers today. Welcome to my pot stream. That should be way down at the bottom at 600 millivolts. We're at negative 100. How do you call this thing? Huh? What do you mean? This is how you start with electronics. Sure, yeah. Yeah. This is what we're doing is we're trying to make an audio mixer using a bunch of eclectic chips. It's really not a good beginner's standpoint for electronics. Oh, that's going the wrong way. Okay, go this way. That's about 600 millivolts. So now we go over to the maximum. What? Ah, my stuff. These pots are slipping out, man. Not helping me. What happened to our adjustment? Okay, there's... Oh. Yeah, that's the max. So now I need to adjust that up to 3 volts. We're at 2.2. 2.3, 2.4, 5, 6, 7, 8. Sorry, I'm doing something really important right now, and it's kind of tough. I've got to keep my head about me. A 3 point, let's say 3.1 volts, because I think we got clipping after 3 volts. So if we take, so we measured that, and now we take it as our control voltage here, and we're taking a look at the output over here. This is not very beginner stuff, no. Oh, wrong one. This one should control. God damn it. Slipping out on me. Okay, here. Well, it certainly doesn't do it to the minimum. Min to max. Min to max. We're looking at this channel, and this one has been doubled with the controls. And if we look at the control voltage itself, that's just nothing. Control voltage itself, with the 2 of them connected, well, it's not moving at all. All right, so a big thing in electronics, a big thing in what we're doing right now is troubleshooting. A lot of what we're doing is troubleshooting, and troubleshooting is eliminating variables. Eliminating variables methodically in order to get to a succinct conclusion. And so what I've been doing is I have been taking this step by step. What we're trying to prove out right now is that the 1 kilo ohm potentiometers versus the 10 kilo ohm potentiometers. The circuit, the thing about it is not everything is what's called high Z. This potentiometer keeps slipping out. I'm going to extend the pins. I'm going to plug it in like this. Piss me off. There, that's a bit more definitive of a connection. So, oh boy, I can't. So yeah, anyway, what we're doing is we are measuring all of the individual little things that are going on and that are going wrong. So what I have is a schematic that I'm following and I'm building, and we're trying to get the full fruition of the schematic done. We're trying to get the full thing built that'll give us all the information that we need to take to designing a PCB. What this is a 4-channel audio mixer that will mix 4 inputs into 1 stereo plug output. It's a little harder than it sounds, because what we need to do is have control over 4 different inputs, 2 by 2 channels. So combining the voltages of the controls here, it unfortunately means that it's not what's called high Z, which means that there is an extremely high resistance on the input, so it doesn't actually affect any more of your circuit. What's going on here when we plug this in is we are putting a bunch of resistors onto 1 voltage that is actually, instead of just being a thing, it's actually a resistor. So it's like there's another component here going to ground. And so that's messing up the mix voltage. This needs to be kind of kept at the same thing. So the question is, do I want to put a buffer in there? And I really don't, because I don't have space on the circuit board. So I was thinking that I could do it just with potentiometers, and I kind of dead reckoned what the values of the potentiometer should be so that we get a particular voltage into that input. But when I include another thing into the input, it seems like everything is changing a little bit. So I have no obligation to make you understand. I'm sorry, I'm in the middle of this. Electronics are weird. You've got wibbly circuits going on, and the voltages are, they distribute amongst other components. You really gotta, you're gonna have to go look up a video on Electronics 101 if you don't understand what I'm talking about. Just go watch, like, there's a lot of foundation here. Once you get over it, I'm just playing with voltages. And when you have resistors on voltages, the voltages change. Yeah, it's just, you walk into a lecture hall and you start asking the professor, what's that number? What's this number? What does that do? I have a degree in physics and I don't understand most of what's going on. This is voltages, come on. It's just, you got voltages that are smashing into each other. What I'm trying to determine right now is what's going on with the input voltages. When I hook up an input voltage to this thing, it's changing. And when I add a second channel to that input voltage, all of a sudden my range of adjustment goes down a lot. So I'm unable to mix these signals properly because I don't get the same voltages in each of the channels. Now, I could put a buffer on it, you know, just put a buffer on it, just do this. And then this, I think, could split to the two outputs. I don't think I need individual op amps on this thing, but that's way more components. Father is a wizard, and this is a page of spellbook. These are runes. You're putting together runes in order to make magical sounds. Quote one of my lectures, you start with Maxwell's equations, and then you are done. What's one thing that you would ask a higher power to definitively answer? And that would be probably Maxwell's equations or turbulence. Those automatic Maxwell RF room planners are great. Those things are crazy. Where should I put my router? So if I take the ding-a-ling away from the other ding-a-ling, because like my square wave ain't squaring, and this isn't adjusting it at all for some reason. This knob is harder to get to. So if I take away the connection to the other amp, oh wait, no, I'm looking at the wrong one. That square wave is just a diminishing, oh no, that's the correct one. We were looking at the correct output, although this is adjust, this is, oh no. This is looking at output. Here's our voltage level. Or what? do you mean it's not changing? What's going on? Why does my whole setup suck? It's like, this is like one of the neatest and organized setup that I've done. This is immaculate. Nothing can go wrong here. And yet it's all going to shit. The more I get closer to an answer on this circuit, the further, ground's not connected. Okay, that's, all right, now we have ground reference. Still nothing. The closer I get to any kind of information about the circuit and its functionality, the further I get from actually seeing it work. Take out our dual controls, take out our output, put it over here. We're looking at this voltage. Now it's changing very, very subtly. Bring that back over here and measure it apart from the piece. So apart from the chip, that is now adjusting properly, and we get our range. So with 30 and 40K, I don't think this has the chutzpah to power the, whatchamacallit, chewy, chocolatey, crunchy Hershey's. I don't think it has the power to put that voltage on the line. You know, in my line of work, I deal with a lot of whatchamacallits. Hershey's completely ruined that phrase. So I have to call things a whatchit and a thingy. I mean, technically it's a thingy, but I don't. Why do they get that word? Have that crap stuck in my head every single time. So up and down voltage level. Or down is not as down as it could down. So let's down the voltage level a little bit more. What direction is that going in? We're looking for negative 600 millivolts. Why did that change? It's like, it significantly changed, didn't it? Negative 600 millivolts. 5, 6, there's 600. That should get us well within clipping range. And then check our maximum again. Just make sure everything's fallen out of tune. 2.1, I want to bring that up to 3. Now, I could do this dead reckoning, and I could do it by just adjusting things like this until I get all the appropriate voltage levels out of this in that system where it's going to 2 channels. That'll mean I have some weird resistors on the board. What would that mean for the end result, the mixer itself? Like if I put something on there and it got warm, what's going to happen? Because like resistances change with heat. So if I have it on a fairly sensitive system for voltages and stuff, I mean, maybe it's okay. How analog, I mean, I wish this thing was freaking digital. Okay, so there's our adjustment range back into this. So I'm going to put that back into the adjustment port, and then we're going to observe it, the voltage range that is, here. Look at that. Look, it's different now. The range is different. It doesn't go fully up to 3.3. Now that I've added this thing in there. So I guess the 1K and the 3K have it. If I'm doing 30K, if I'm doing the times 10, then it needs to go into some kind of a buffer. Maybe we do need a buffer. I'm a React developer. It made me so humble when I see a simple board and oscilloscope. Dude, it's amazing to work like this. This feels great. I'm able to quickly come up with suppositions and then put them down onto something where I can suppress them and bring them into fruition. And what we're trying to do is we've got a lot of these new chips. These new chips are voltage-controlled amplifier chips. So that's, you know, the basic premise of a mixer. And then we have them going into a second one of these chips where it'll be an overall volume output control. And then, of course, because I'm terrible with audio stuff, I'm putting it into just a headphone amplifier. It's just, where did the cat go? Do we lose Thurston? No, there's Thurston. The Thurston emote was very small, but when I think about use state, uses something like this in microscale. I don't know what any of those words are. But yeah, this is unfortunately very complicated, and the amount of space that we have is very minimal. If I show it on AutoCAD, I'll start up Fusion, but we have another thing that we got to work on. So we got to figure out what's going on with these voltages. It seems like, I mean, if I put it into a buffer amplifier, am I going to have room for that? I could put in a singular amplifier, TL0724 equivalent, and we can see if that chip will actually fit on our board. I would need 3 channels, so they don't sell anything in 3s, and I'll eat my hat if I have an amplifier that hangs out that's not being used. Micro shops. I mean, audio is digital. Like, that makes sense. Audio is very analog, but in this day and age, audio has gone very, very digital. And so if you have digital stuff, you really need to know a lot about voltages. And to know voltages, you need to know electrical engineering. And when you know electrical engineering, you start to get to know chips. It all comes hand in hand. It's full circle, nose to tail. All right, let's get this thing open. I wish they would implement night mode already. I think one of the dev branches has night mode. So eventually I won't, you know, flashbang all you guys. Okay, so update later. We're looking at mixer. What did I call it again? Mod, test mod, panel tabs, skip. Oh yeah, Jules's absurd volume knob. And then this one is just what we want to open up. It'll open up the whole project. We're just going to see if I feel like I have room, because this is the panel. It's a very, very small amount of space. I was going to put another amp in there to have clipping indicators, but I don't know if that's going to happen yet. So over here, we have the incredibly small op-amp IC. We also have the slightly less small, but still incredibly small headphone amplifier chip. Those are all here. So those look like they're hanging out. They got all the room in the world to function. But when you start adding the resistors and the capacitors and you start trying to get stuff into position, you start to lose all this space. Let's open up the whole project. And right now that is 12, well, it's 8 amplifiers and then the headphone amp. And we're using, if we're going to use 3 of those on the knobs, we need 2 for the output. Oh, it's not looking good. Oh, did I not put down the right? I didn't put down the right thing. I see. So yeah, if I go to the, not design manager, the place components. And we'll do a specific AutoCAD stream on this stuff, so it's a little bit more clear what I'm doing. I'm just kind of trying to get all this stuff down and see if we have room. The, let's see, chips managed, and I'm looking for TLO. I don't know if I didn't make the little one, the one that's just an SO IC sized. It's SO8. Do I have any other chips here that are SO8 that I can just throw down on the board just to get a sense of the, yep, that one right there. So this LDO is, we're not using this LDO, but what I'm thinking is that maybe each of these knobs has one of these things on it. So doot, doot, and doot. Done. Because this size chip gets me 1 amplifier in there. Let's just see what that does to my 2-dimensional design if it stresses it out too much. So these would be on the underside of the board. We'll have to flip the layers around and change the view stuff to make it a little bit more equitable. Those will barely fit there, and then I don't have space for traces to go in and out. But if I have one of those on each of these, I mean, we're getting up there in the number of things that I am accommodating. Oh, whoops. No. Control Z that. Those are in very specific locations. I have to be careful that I don't click and drag them. The worst is when you click and drag something out of its very specific location, and then you accidentally click and drag again. Wait, I thought, why are there 4? Did I put 4 down? It's supposed to be 3. And we'll test the circuit in just a second too. So I didn't need 4. Let's go back over here. Schematic. Basically what you're doing, oh, I see, I must have misclicked. And back over here. So the 2D drawing is pretty much the star of the show here, but you get these little extras like the schematic tells you where all the air wires are supposed to be connected, and that allows you to design the thing a little bit more easily. The 2D drawing is all that we're supposed to be generating with these files, but then the last part of this is the 3-dimensional layout, which is a total bonus, but it really, really helps us make the decisions that I'm making right now, which are the size and the layout and all that stuff. Is it going to be possible for me to build this on one PCB? Because the cost of this thing goes up significantly. And I know Julian wants to sell these. I don't know the first thing about the responsibilities that I would be involved with when selling something like this. That's a big egg to hatch. And I'm willing to go with Julian on it. And I know you guys would probably, a couple of you out there would love to buy this mixer, but oh man, it's just responsibility. Look at how much larger this thing is than the chips that we're using. My God. But then in addition to that, I need the 2 cool audio chips, which probably live in the larger area of this. If I can get the 2 cool audio chips on this as well, ooh, this is a lot. But if I do op-amp voltage-controlled mixer Eurorack, maybe we can come up with a circuit that doesn't need the cool audio stuff. Seems like we put a lot of our eggs into that basket. So, it would be voltage-controlled. What's up, Ryan Labs? Audio mixer, op-amp. Oop. Why audio? Well, that's what Eurorack is. That's cool. You can put all the it's like a modular. That's neat. That's a lot of parts though in that mixer. Genuine, you get a genuine Oh Bother mixer, which includes Willow's hair underneath the chips. It's been kind of. What are you talking? No schematic? Ooh, look at that. Why would you do the thing that you're doing right now? I don't know. I actually don't know. I'm not very responsible. Oh, he's using a V2164. V2162 gain cells can be summed up to a single op-amp current to voltage converter. Fit the op-amp and its passive components on one channel. The device. See, when you get to Eurorack, everybody's using this V2164. But that chip is going to be huge. It's going to be absolutely enormous. Here, I'll show you. We'll put an SO16 down. Is it SO16? It's SO16, yeah. Audio is ruler of ohms and watts. No, it's not, man. Audio is just one little subcategory in a big world of voltages. I got sucked into the modular synthesizer stuff because I have a friend who got into all the modular stuff, and he basically said, hey, if you could just buy the circuit boards and they give you no information about what you're supposed to build. And I was like, that's me, that's my speed, I love that. So I bought a bunch of the circuit boards and putting together a little synthesizer. It also came at a time when copyright strikes were getting huge on Twitch. So if you wanted to supplement your stream with any kind of audio, it was to be considered stolen and you would be arrested on site. So I wanted to have something that would be able to make pleasing little bleeps and bloops in the background. And I've been working towards that for over a year now. It's been a lot of work. But like, I don't know what's going on. We just have got a mental patient. It's just a mental patient, that's all. All right, what was I looking up? V2164. I was trying to find a good schematic that didn't use this stuff as mixers, but I don't think I'm going to be able to get there. This is a crazy design, this thing. Oh, we were going to throw up is basically what I feel about right now. Hold on, let's get this window managed. Why does it never remember? Fusion never remembers the size of my window. Since I stream, I've got all these vanity panels on the side. I don't know, maybe I should do the VTuber thing when we're going through this stuff. I can get my VTuber over here and we can have that activated. I can just turn it into like a basic 2-panel VTuber. All right, we're going to put an SOIC16 into the design just to see if it fits. So we go back to the schematic. And I want to, in addition to all this stuff, I'm going to add an SO16 to SO16. So we go to Parts Manager, Place Component, and I'm just going to find anything, and it'll probably be another amp. One that I can identify from the others. So MCP 6004 should be fine. And I'll just choose the variants that I didn't name individually. Ah, great. Well, choose the D variant. Let's put it off to the side here. 1, 2, 3, 4. 1, 2, 3, 4. Done. Okay, so now over to here. Once you have some working synth modules, it might be cool to run the fart box through it. Oh, that would make some weird farts. And I guess that's why we're all here. Yeah, that would be actually excellent. So this would be the cool audio chip. Flip it over to the other layer. Oh, we need to do special rules in order to fit a chip of this size into this design. So on the position, I can put it at 10, I think. Oh, no, not 10. Nope, up here. This one to, what was it? It was 10, so I think we're taking it to 5. Oh, no, never mind. Oh, I see. Yeah, it bumps it back out to 8 because it doesn't let you do that. Yeah, PCB and Fusion, that's what I use. It's why AutoCAD has gracefully, gleefully, I don't know, I forget the word. No. AutoCAD allows me to do sponsored streams now, which is why I can get my license and not have to fake being a teacher and get the fully licensed, wonderful version of their software. I use Fusion anyway. I use it to do 3D printed solids on stuff, and it's a lot of the like for the RC car, for this thingy wingy here, and for the modules that I'm building out of other people's PCBs. I'll use Fusion 360 to design the panels and stuff, and then 3D print them. But yeah, that's what we've been using, and so Fusion found my stream as a result of that, and they said, "Hey, bother, we can give you a new version." And I said, "I'm ignoring your email because I don't trust anyone." And so I ignored their email for months, and then it turned out that my license was expiring, and I went, "Oh no, my license is expiring. I'm still a teacher." And then they said, "Huh, prove it." And I said, "So about that creators program," and now I have my free version. So, and a cool RC car. Look at this thing, it's awesome. But yeah, anyway, so I didn't so much get caught as I got caught up. But yeah, I've been using Eagle for a long time, and I know a lot about Eagle, the PCB software. So Fusion bringing in Eagle and then having 3-dimensional circuit boards is just a perfect combination of storms, I guess. And so I'm locked in with Autodesk. Why audio is so closely coupled with knowledge from microchips? Because waves. Easy EDA. I don't hear a lot of people coming in and talking about easy EDA. Most of what people say is KiCad is the de facto standard for doing PCBs on the level that we do them. We're hobbyists. You know, as much as I am a professional EE and I have received a paycheck to be a professional EE, the paycheck that says electrical engineer, which means I am an electrical engineer in America. We don't have like a doctorate association with it. I don't take a professional exam. But in so much as I call myself an EE, we are still doing hobby level projects. Even this audio stuff is hobby level. We're sort of down here doing kind of the, oh, this is a neat thing you can do level stuff. So we got into a little bit of actual engineering with the mixer at first. And if I really did like do equations and stuff, no IEEE puffery in here. I was a member for a little while, quite a little while. I just let it lapse because it was really not useful for me. It didn't do anything for me. I'm an entertainer. I'm a clown. When it comes down to it, clown. Just I don't put on face paint, but the mental face paint every day. Mental face paint. No. We're having a little trouble on here on the mixer circuit because things are weird. Our voltage levels are kind of moving where they shouldn't, and it's stuff that is going to relate back to real electrical engineering eventually, but it's like the voltage swing that I'm getting here. Let's get the distracting stuff off of the screen. And I'll zoom in a little bit so that we can see. We're looking at just a voltage level, so this is like a multimeter kind of task. But if I swing the voltages up, swing the voltages down, that range should be 2 volts 3 volts rather, to negative 600 millivolts. But for some reason, it's not today. I don't know what's going on here. If it's just the way that I set this up, I think it's what's happening with this circuit. This circuit does not have a lot of amps behind it. So here's what we're going to do. We're going to keep the 1030K whatever, not go down to 1K, because when I plug in multiple outputs, it seems to be influencing that voltage. So instead, what I'm going to do is grab this TL072 dual amplifier that's been sitting on the desk for, where did it go? It was sitting on the desk for months. The minute I clean it up, I need it. The minute I clean up around here, all the stuff that I was looking for. I don't know what this chip is. Over there. I save little pieces of things over here, but yeah, all right. I gotta find. We'll get it out of the through-hole bin. I don't think I put it away. I think I just threw it somewhere else. Let's find an op amp. Let's find an op amp. So I got them in here. Actually, I am running out of those. Hold on a second. Let me see if I can find one over here. TL072. This is just a 12-volt stable. All right, let's hook it up to one of the tiny ones then. We'll use one of the tiny ones. Get wrecked. Now, the second I need something, we can hook it up to one of the unused amps over here. These are a little bit more clumsy to use because the way that the outputs are organized. Oh, that's wow! I really set that guy off. Thanks, Gonad. I don't know what was going on with that. Yeah, I see now. I see now. All right, well, whatever. Whatever it is. Okay, so what we're going to do is we're going to hook up another one of these things and see if buffering solves all of our problems. Because what I think is going on is that there is a resistor. Basically, okay, hold on. The cool audio chip, from reading about another one, not this one, for the one that I chose has like no information in the data sheet. But from what I'm thinking, the input is acting as a resistor. And so if we add a resistor to our little happy little, yeah, GG mod, indeed. I mean, look, we know that type. We've seen that type before. I generally try not to have anything happen there, but it's like the what do you call it? Attention market. It's basically, I can't. Okay, so this circuit, it's like we're adding another resistor here to ground or to whatever. So it influences what that voltage level is. And so I thought that smaller resistors on the ups and downs meant that more current would be flowing out of these and it could get to that voltage faster. But it seems like we need something that's actively going to be pumping current into that stage, which is really just kind of really pisses me off about this actual, what do you call it? This actual circuit kind of really annoys me. This chip, this cool audio chip, should really have high Z inputs. I don't know why they would allow that to happen, because we are just trying to influence a voltage level onto that pin. Having that be a resistor in and of itself means that I can't just simply put a voltage divider into it and have it be at a level. I don't understand why that's the case. That's sort of the confusing part about what I'm trying to reconcile here. I'm trying to pull my brain out of that part of the equation and see how we can actually work with that. But it's like, how do you expect people to do like non-standard weird mixing like this? But does that mean that I'm going to have an amplifier at each of these in order to maintain a specific voltage level? Or do I just need one on the input as a buffer in order to influence it? So we need two, probably 100Ks, so 100, 100, and then that needs to go across this thing. So let's get that all done up. Yeah, this is a nice position to be in because I can just very rapidly throw up these circuits and see whether or not what we're doing works. You know, seeing it in the real world is very nice, as opposed to designing. But like some of the problems we were dealing with earlier, you know, waves being in weird places. So we're going to use probably A. So 15, 1 and 2, and between 1 and pin 15, we will have a 100K resistor. 1 hundos. Let me find the hundos. Where are the 100Ks? Where's my resistors? Oh, they're all the way back here. Hold on. I didn't think we need these things. I am a clown, though. I mean, like, honestly, like, you guys don't... I'm just here to go doo-dee-doo-dee-doo, and you guys are entertained. Like, that's what I do. I don't think there's any arguing any other stance on that. Let's be realistic. Okay, these are the 10Ks. Jesus Christ. What? I've been taking... Look at the... I have not just been taking these from one side this whole time. All right, so... Oh, these are 10K. Wait a minute. What does that look like? That looks like a 10. 39. Where are my 1Ks? 5.6M. 100K. There we go. There's my buddies right here. These 100 kilo ohms. Yeah, I think they heard the word, and since people are associating the word with really bad stuff these days, yeah. Between pins, what is it? 1 and 15. I'm here to learn stuff from the clown. The clown teaches you things like how to juggle 1 and 15 here and here. Oh no, here and here. What's the other one? The other one is 14 and 12. 12 and 4. We could do 12 and 14. Let's do 12 and 14. Oh my God, somebody just walked across the floor and it made something click behind me. Here be giants. All right, so like this. This is my special expensive tool. Part of what makes me into a clown. This is a $75 retail form bending tool that I stole from the government. Of course, it wasn't that much back then, but... so pin... Did I get it right? In D minus, which is pin 12, and pin 14. I didn't get it right. I did it one extra space. Yeah, it would be 3 pence to 3D print. Yeah, it would. That wouldn't be a difficult thing to do. It's just 3D print one. You wouldn't have these little measuring things, these little spikes, but you could easily furbish something like that. I mean, I could design something like this in an afternoon. Maybe we should. Yeah, I haven't modeled it for 3D printing, but there are versions of stuff like this. Maybe we should make one with a little set screw. We could simplify some of these forms a little bit. These could be flat on the bottom so that they print cleanly on the bottom of the 3D printer. This would be maybe just like a screw through the side. And so you'd print these two flat. This is a tough one, this undercut. But then give it the little screw thing and then just a regular old normal post. There's also a couple tools on the back end of this thing, but I never use them. So all I'd really need is just the spikes, and they would just need to fit into there. This would be not a hard thing to 3D print, to be honest. And maybe I could do supports in there, and then you just, you know, peel them out and then glue the top. All right, so this resistor goes into the feedback loop. 100K, 100K means you're limiting the current severely but you're giving it a 1-to-1. Yeah, we can see that. Working on that. So pin 12 is minus in D, and pin 14 is out D. In and D out. And so into D, we will have the voltage over here. So I'm just going to jump out to this open area over this way. I mean, I could go into these middle pins. We've got 4 pins here that I could use, so I could put the other 100K into here. Maybe I'll do that. So let's move in. Let's move this. Well, actually, we can move. Yeah, we'll move this one in. This one in. Is this off? It's not off. I'm working on it live. Turn it off. Turn it off. Turn it off. I don't want to blow anything up. That goes there, and then we'll put one to whatever the size of the resistor gets us to. And these are 100Ks. Almost had a Labalanche. What are these? Those are 4.7 or something. All right, another 100K. And this one is just going to be the size of the resistor. So we'll just bend these directly down and just cut them at length. These little cutoffs are the worst. They get into socks, and then they're like little syringes. And that's not going to an active pin. That's going to a pin that's not utilized. So now I can put my control in here, and I can get it out on pin 14. So if I put the control over here, well, I'm going to use the more stable one, the one with the 1Ks, because it's just easier to use. Well, no, we should keep using our hardware. Keep using the hardware that we're using in the end thing. So we put it out to the input. Oh, no, the input here. And so now on pin 14, we're going to observe. What? Wait a minute. Hello? Where's our, huh? Why is it all the way over there? Oh, it's inverting. God damn it. Wait a minute. Oh, we didn't reference to ground. Reference to ground. We forgot the ground pin. The positive input needs to go to ground, or if we want to do non-inverting op amp. Then again, I can just invert the Chatterino's frozen. Oh, there's a bunch of Pace Conform 1 lead bending and component forming tool on Amazon for $50. Oh, we just got in a bunch of messages. I see how it's gone. Yeah, we could use that in 3D printing. That would be a good project. It could be that I booted Fusion and my overlays did something. Oh yeah, this overlay died too. Okay. Yeah, when I open up Fusion, it takes up a lot of memory on the computer, and then Chrome starts to sundown all of my tabs in the background. So I just need to go up here to chat. No, that's not. Backseaters, microscope. Oh yeah, chat has its own little thing, right? Where did I put this stuff? Man. I see. Get overlays out of here. There we go. So properties, and then I can go down here and I can refresh the cache. Oh my God, everything's fixed now. I don't know how I lived without a 3D printer. Yeah, I kind of am at that point as well. It's just one of those things. Am I on 32 gigs? I don't know. Yeah, see, 77% of my memory. And I've got 16 gigs. So I think I may be in for a round of upgrades on the streaming computer. My old gaming computer is sitting in the other room. I think it might have less of a processor on it, but it'll have more than 16 gigs. everybody, you know, for a long time, everybody was like, you don't need 16 gigs. You don't need 16 gigs. You don't don't put more than 16 gigs in your computer. And I'm like, are you guys dumb? Like, have you not paid attention to the direction that computers go? Like, it always, towards the end of the life of a computer, it's always super duper important that you got the maximum amount of RAM that you could get for your budget. Like, you don't buy cheap power supplies and always get more memory than you think you should. Don't listen to people on the internet because they always say you're only ever going to need 16 gigs of RAM. Yeah, maybe you will if you're running Jedi Knight 2 and that's it. Like, but I have streaming programs, I have CAD programs, I have everything running on this computer at once. And somebody somewhere along the line convinced me that all I'm going to need to ever use is 16 gigs. I'll never need to use more gigs than that. But like, your web browser is a goldfish that grows to the size of its container, and suddenly everybody's talking about having 75 tabs up. It's maddening. It's just so maddening that the conversation for a while, and this is related, people just say, oh, computer audio is good now. You don't need to buy anything else to do audio on your computer. No, computer audio is fine. No, it's not. No, it's not. No, it's not. It's passable in every sense, but it's not fine. The problem is that I had a memory stick go bad, and the memory stick was locked to whatever chipset. And so I had to switch chipsets on this computer, and I bought a whole new round of hardware, so I didn't have the money to be super duper upgrading. That said, the computer that I've got collecting dust, my old gaming computer, that one is probably, I could probably swap that in here, and we could get a nice thing going with it. But yeah. What about 64? Do I actually have 64 gigs? Watching the rewind to get your pee from fit powders. What? Kavorka, if you hadn't already said things into my chat, I would be wondering if you were some kind of a bot. Fusion is like 7 to 10 gigs. Yeah. Well, but I'm also using the PCB stuff. It runs well. So do we want a non-inverting? Do we want a non-inverting? The control function would be, well, I want unity gain. Are we able to do unity gain with a non-inverting amplifier on a, because R1 and R2 are going to be 1, and it's 1 plus 1. We get a gain of 2. We want it to be 2 over 1. Oh. Yeah. I don't think I got the emails. Really, Discord is the best way to reach me for stuff. V1 is equal to R2 over R2 plus RF times V out, but that's, yeah, our transfer function is 1 plus RF over R2. So R feedback over R2. If they're both 100K, we get 1, and then we get 1 plus 1. So we really want 1 plus nothing. I don't know if that really... Yeah, I mean, the computer's been fine. It's been okay. It's just sometimes it'll end of life, or I keep saying that, sundown some of these tabs. Yeah, RF is 0, and then we have 0, 1 plus 0. Unity gain buffer. If we make the feedback resistor RF equal to 0, resistor R2 equal to infinity, then the result of the circuit will have a fixed gain of 1. And all the output voltage is fed back into the inverting terminal. Oh, okay. So we need a wire. We put the wrong thing down. They may look like resistors, but they are wires. Yeah. So the reason that the signal was all crunchy like that was that I didn't reference it to anything. The op amp is a very high gain observer of 2 voltage levels on the plus and the minus. And when you do those feedback loops, it cancels out all of that extra gain. So what we need to do is have just a simple loopity-hoop, from out to minus. So instead of that longer resistor, I need just a jumper, so that whatever's coming in can cancel out. So here's a jumper the same size, and we just put that, and it's a red wire to show you how dangerous it is. Pin, oh, what was my pin out? Losing my marbles. God, that really was like an attention span bomb, wasn't it? We're using in D. Oh, indeed. -2 output is 12 to 14. To 14, just like this. See, the reason that we've got, I've got these different op amps, so our pinouts are all weird. I'm wondering if I could have twisted this and had it be a little bit more logical. I think I might have been able to, like, move this 90 degrees over. I was too scared because pin 1, knowing what pin 1 is and having that correlate to actually being pin 1 is a much better feature. But yeah, okay, so if we've done that, and now the other pin does what? That's our input. So our input is on pin, pineapple pizza pin. Our input is on pin 11. Yeah, it's just straight up our input, as long as it stays within the voltage characteristics of the op amp. That's our input. This is our output. So let's observe it. Turn it on, and there's a voltage level. Take it up to 3, down to 0. It's not doing anything. 0, 3. Zoom in on it. Oh, I was adjusting the wrong one. Ah, there it is. Here, let's do this. This is a better view. My hands are covering this thing, so. Look at that. Beautiful. All the way up and all the way down. We got a little buffer going on. I could add a little capacitor in there if I really wanted to. This is, I know, it's like, this is what we're getting excited about. This is a changing voltage level from -600 millivolts. Well, we got to adjust that -600 again. Let's make that get a little bit more stable. We have to celebrate these victories lest we cry openly, lest we weep openly on stream. Twitch probably doesn't appreciate. Is there a crying category? Can I social crying? Where we just openly weep with each other? I mean, that's about as what is it called? Parasocial as it gets. Yes? I would assume that there is. Just kids crying. Far Cry 5. I liked Far Cry 5. That's the one I really liked. I think Cultists is a great enemy. And then to have, can I spoiler Far Cry 5? Is that kosher? Maybe not. I just really like the ending. I really liked the ending a lot. And the fact that they made just the stuff that the internet gets up to. They made a song that was supposed to parody gun nuts, and it ended up becoming like an anthem for gun nuts. They made 6. There is a Far Cry 6. Played the first one and then lost interest. They are very samey. Oh crap! My whole number line moved. They can be very samey. I think I was adjusting the wrong one. I think the lower voltage is on this one. Let's go to the upper voltage. Did Tektronix had a surplus store? That sounds awesome. Yeah, now there's just a whole surplus market for scope stuff. It's just the whole market. 5. There's 6. There's 6. Okay, now we go the other way. Now this is supposed to be the upper limit. Take that to 3. 3.3. And let's just double check. Oh, this is that whole moving two things at once thing. This is where stuff gets a little weird. We need to get this down to -6 while simultaneously allowing the upper limit to go all the way to its number. I don't know how often I'm going to be doing this. Because see, now we're significantly below 3.3. Well, I guess the whole point of what we're trying to hook up is to see whether or not a buffer is needed. So now I'm going to take this signal and we're going to go into the amplifier. And we can observe the voltage level. We can continue to observe the voltage level right here. And we can just see if I add the other amplifier into the control scheme. It doesn't appear to change it at all because it's able to output that additional current. So as long as I can get these tuned properly to give us the proper range, then if we're going into a buffer amplifier, we should be honky-dory. And I can continue to use the 10K stuff. I don't know how much extra current I'm drawing. It does look like that needle's moved a little bit, but not much. Let's check. You got a spectrum analyzer? Dude, I want one. There's an $800 one that's portable, which is really nice. But it's $800. Oh, wait, I shouldn't be able to see a square wave here. Should be over here. Let's look at the waveforms. So in order to view the waveforms, I have to put it through a different amplifier that's in a current control configuration. So here's that. And then here it is coming out of the mixer. It's small. We can make it big. That seems to be a little hot. Oh, no, it's not. It gets up to 10 volts. All the way down to 0. 10 volts, 0. 10 volts, 0. I may have to look up how to do like a voltage specific circuit. It failed in 2020. I was around the late 2007-ish, 9. I was looking them up, and there's a really nice one from, ooh, who is that? It was a battery-powered one. I'm sure it's super obsolete now, though, because like all the Chinese scope manufacturers are starting to make stuff that's like really competent, and so it affects us. Like it's like, oh crap, now I can make like I can get like a full spectrum analyzer that rivals the secondary market in everything but price. It's like a 15th of the price. Used to, like, man, $15,000 was not a lot to spend on a scope if you were a business. Craziness. But nowadays, like, yeah, that secondary market, if you need to get something that's close and you're not doing government work, like, yeah. Craziness. So this is keeping our voltage level at the adjustment points the same. It is able to output enough current. Of course, whoa. What the? Why are you doing that? Wait a minute. Oh, we're viewing out the amplifier. Oh. I just plugged something in that was totally wrong. Totally wrong. Yeah, this is the input, and so I want to observe that input over here. If I look at the voltage level here, that voltage level is not being observed. Okay. Hold on a minute. I can figure this out. Oh, yeah, here. Okay. Who's the wise guy? That's not supposed to go there. This is supposed to go, no, this is supposed to go here. That I'm observing. And then I'm sending my output. Oh, wait, this is my control. There. This is why we use different color wires, because things get confusing. Yeah, there we go. See, there's just that little bit of adjustment. Although it doesn't appear No, yeah, that gets to 3 volts. So see, this is still able to maintain the output, which means, oh God, that means I still need 3 channels to do. I need 1 channel per knob. So that's three more channels on this thing in order to do the mixed. That's so annoying. That's so annoying. I don't know what to do about that. I guess I just have to put 3 more op amps into here. I guess they don't need to be the individuals. I can fit a 3rd chip. Right, for knobs. I can't believe that. The one thing in their design, if they could have baked the buffer into their design or something to give me high Z on those voltage inputs so that I could do the logical step of having something that drops a voltage on a line and expects the reciprocant voltage to control how the amplitude of the signal coming out. Like, this is crazy to me that we would need this entire system to control it like this, but apparently we do, because they're not high Z. They sap current out of the thing you hook up. Why? It would be more engineering on their part, and they're not a big engineering operation, I suppose, is all I can really come up with. But which one was it? There was another one that talked about this effect, and I think it was the Dad I'd Like, the DIL. Maybe it was the DILF version of the chip. This one is Alpha Repar. AS20. Oh, I love it when they do this. Preliminary. Why did you put that in diagonal on your... Ugh. 2164, 4 independent controlled amplifiers in a single package, high performance, provided very low cost per VCA, resulting in excellent value for cost-sensitive gain control applications. I still feel like there might be another type of circuit that would do this job for me. Each VCA offers current input and output for maximum design flexibility. Blah, 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 blah. Single resistor tailors operation between full Class A and AB model. I still don't really know if where I would want A or AB. I don't understand that. Has to do with how it crosses 0, right? Internally protected in situations where negative supply is turned off. That's nice. That's nice when the chips don't all explode. Basically, same deal as the other one. You just have these little VCA units that are inside the chip. Signal, signal, signal. Typical application, test, and circuit. Thing is, they don't really go over that input. I guess you could look at this diagram and it can give you an idea of what's going on inside, but simplified schematic of 1 channel. So our control input, that doesn't really give us too much. Oh, this is a very rudimentary data sheet. This does not give us anything. This is the wrong one to click. Maybe it was the smart one, the SMT. No, they're not giving us application information. We need to know how to use your thing. 2164M. I think that's the one. Yeah, we're using the 2164M. The D. 2164D. Same thing. Cool audio. One of the data sheets had more information. Yeah, the data sheet needs to be comprehensive, but I don't think the people producing these things had the ability at the time to make them comprehensive. This one at least has a couple little sample circuits, but there was another one that talked about the need for a buffer on the inputs, which is, I'm just mad at that. I'm very mad at that. Wait, these are related. Quad. Huh. Oh, maybe the SSI was the one. Yeah, I kind of remember it now. So the sound, these are the original sound semiconductors. Damn, that's how you do a logo. That's how you do a logo on a chip. Look at that. Beautiful. Yeah, this one was the better data sheet. Versatile VCA building block for high-performance audio applications. 4 independent channels provide voltage control of current mode inputs and outputs for a gain range of 20 dB to -100. With control provided by a ground reference -33 volt per dB constant, the SSI 2164 blah, 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 will directly retrofit existing SSM V2164. Device offers flexibility, blah, 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 marketing wank. Marketing wank, marketing wank. And then we come down here and we get a much more comprehensive idea of how to use their chip. Now, they're doing pretty similar stuff. I mean, 10 microfarad just to pop your waveform back into the center of things. 20 kilo ohms across 220 ohm resistors. It's a little tweak on the input values. We haven't done anything to tweak those input values yet. This is where like the engineers are separated from the people just play. I don't know. I feel like I don't know anything when it comes to like, well, why did you select that specific resistor? Maybe maybe if we go into the frequency domain a little bit more, we'd understand that better. If we actually gave like changing frequencies to our circuit, and then we could run around with those equations. 4-channel amplifier from blah, 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 independent current control, separate voltage control port. The only mode control affects all 4 channels. Otherwise, designers have great latitude. What about longitude? Of each channel given an application. Basic operation is described below. Input. Figure 1 shows the basic application circuit for 1 channel. We're very familiar. A resistor converts the voltage to an input current, and a 220 ohm resistor in series with the 1200 PF capacitor connected to ground ensures stable operation. The SS blah is quite tolerant of RC network selection, but 220 ohm 1200 PF has been proven to work well over a wide range of RIN values. Blah 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 blah. 20K RN is recommended for most applications. 75 to 100K lower values will produce the best noise performance at some cost in distortion. I guess 30 is just still within their range. Audio stuff gets really weird. It really does. It really does. And there's a lot of like high level understanding of analog systems that I don't think I really have. Yeah, there's a lot of that in there too, the scamming and the sort of like the audio is happy here. Oh, it's sad here. There's a lot of that sort of stuff from people trying to sell you some snake oil. Pulling patents help with circuit description. How does that? Oh, I see. That's interesting. I've never done that. I've never tried that. So to get more information about the operation of a component, you could go to the patent where they're required to simply explain it in technical language. Yeah. I think we've jumped to patents only once or twice, and it was chat making me do it because they actually found legitimate information about the thing that we were reverse engineering, and they were able to go all the way back to the patents and figure it out. It's pretty cool. The output current pin should be maintained at virtual ground using external amplifiers such as TL072. Feedback shown results in unity gain. Feedback shown results in unity gain. Okay. Many op amps require a feedback capacitor to preserve margin. A value of 100 PF will suffice in most cases. Oh, thanks for designing it for me. Jeez. I can figure it out on my own, Dad. Jeez. Tell me to use 100 PF. You do what you must. Yeah, I know. It's like we've got to get down here and we got to fight dirty when it comes to reverse engineering sometimes. High frequency noise expands the bandwidth. What the 100 PF does is as you get to that higher frequency, it starts letting stuff through. Or no, it starts resisting more stuff, and when it resists more stuff, I forget which one it is. Either way, you can think of it as being activated by the higher frequencies, and when the higher frequencies activate, they encounter higher gain. Yeah, God. $30 DAC chip in a headphone box when you could just get something for like $15.99, and it ends up being this is the heart of what we're building right now. This is the headphone amplifier chip. There's a little board that I can plug in and make it work and see how it functions. But yeah, it's audiophile stuff is crazy. They will repackage, and that's one thing that that's so very similar to what you're talking about, where you have the guy who makes the DAC chip thing and it's suddenly $3,000. I wish I could enter a space where I am the one guy who provides something RF that is literally just a box with a bunch of copper tape on the inside and a single resistor. And all of the RF that do something or other rely on this little $50,000 box that just has one resistor in it. And they all pay it. This is government. They go, we would love to test that, but we need to have that box that costs $50,000. In most cases, headroom will be limited by the op amp. Increased headroom can be achieved by using rail-to-rail amplifier. Unlike many VCAs, output current has the same polarity as the input. That's not what we found. Wait. What? What? What's the matter with you? Hold on a minute. Oh, do we not have a... There we go. Square. Oh, that's the wibbly one. We want the up and down one. That is out of phase. Why is it out of phase on my system? We're using the amp output. I guess maybe that's what it is. The chip itself isn't doing it. It's just their output stage inverts. I think that's what it is. That means we're going to need more amplifiers. Tom Evans 30K preamp mend it mark takedown is having what? The Tom Evans 30K preamp mend it mark takedown is having the Streisand effect. There should be so many hyphens in that to help me out. I don't know where any of the punctuation should be. 30K preamp mend it mark takedown. Got to keep your RF traces curvy so the electrons don't fall off corners. Yeah, you got to give them a little, maybe bank it a little bit too. You got to bank the turns. Bank the turns just a little bit. All right, we've got so much extra information here. I need to read the data sheet. I need to actually read the data sheet and process it properly in order to figure out what we're going to do. This is the point where I'm kind of dangling off the edge going, how am I going to make this circuit without it being this whole thing of like 500 op amps? Oh, I think that's missed me. A lot of the culture, the fixing channel stuff culture misses me. We are a tiny channel here. You have to know. It looks like I'm up there with all the greats, right? And it's really humbling when somebody like, Strange Parts comes on Twitch and they look and they go, this guy's up here at the top. Look at what he's doing. But like the difference between me and a legitimate YouTuber, the gap is vast. We have an audience here. We have regulars. It's really nice. We're in a good place, especially for an EE stream. Really cool stuff. I am microscopic on both Twitch and YouTube. On YouTube, I'm nothing. I'm subatomic. But around here on Twitch, in terms of EE, I'm a big guy. But it doesn't seem that, So when big things happen in the EE or the makers subculture, I miss it. I don't know anything about it. MetaMark got a malicious copyright strike for reversing a Tom Evans 30K preamp and fixing it. That's funny. That's actually hilarious. It's like, I don't know, there should be like a legal precedent for you had it coming. If you're going to sell people snake oil and it's just engine oil, people are going to know. Hey, Solid Electronics, thank you for subscribing. Sometimes people subscribe on Twitch. Yeah. And I appreciate when they do. It helps the channel out immensely. Yeah, the reducing jitter stuff, what they'll sell you, people have been printing cable stands so that your cables don't droop down onto the floor. And you put your cable up in a stand and it's made out of a specific type of glass that's really good for, probably you can get quartz ones and it'll be even more insulative. You can just 3D print them or you can just have fucking wires on the floor. It doesn't matter. You guys are beyond, oh my God. I understand, stop the ground from getting to ground. Coat hanger. In 97, 98, I worked at a speaker repair shop. Oh, that was the heyday. That in the early 2000s for home theater stuff. Home theater blew up in the early 2000s. Budget says I can't afford to subscribe, but at least my Turbo subscription pays like half a cent more than an ad view. Hey, whatever, man. I appreciate you don't need to contribute. I appreciate you people who do. That's it. That's all there is to it, man. Your presence in the chat is more than enough. You guys are totally cool. I would love to blow up. I would love it if this channel would blow up. Everybody seems to think that my channel is going to blow up at some point. That's what all the advertisers think. They're like, this guy's going to blow up any minute now. And yeah, maybe I'm going to like fart, but like blowing up, like in terms of people watching, I would love that. We had a pandemic that forced everybody inside, and they all started watching stuff inside, and they did not choose to watch me. So that should say it right there. Engaging in chat, something I can do. It's something I really appreciate. And if you don't engage in chat and you're just watching, okay. I have no system by which to judge you. The output current pin should be maintained at virtual ground using an amplifier. We got through that. Control port. Here's the important paragraph that I was talking about. The SSI 2164, not the one that I bought, but the one that's very similar. It's almost completely similar. Provides exponential control with a gain constant of 33 millivolts per dB, negative 33 per dB. So it's exponential. To realize the full gain range of plus 20 dB to minus 100 dB control voltage should span from negative 660 millivolts to 3.3 volts, respectively. If only attenuation is desired, the control board can be driven directly from a low impedance voltage output DAC. On my live stream this morning, somebody referred me to you. Oh, that's cool. That's cool. I guess there's only so many people. Check out the fancy emotes Twitch is doing. Is that going to do anything to my... If that does something externally to my stream, I'll have no idea. I've had people use those cheer effects where Twitch overlays stuff against your will. Yeah, the blinking light emote is pretty cool, cute. I like that one. In college, I used an old phone cord to get SPDIF audio from one side of the room to the other. There's also exposed alligator clips involved. Worked perfectly. That's awesome. Listen to that SPDIF. Yeah, the audio and superstition are like hand in hand. It's very annoying. The control input has a nominal impedance of 10K. This is what we've been using. This is what we've been dealing with. An internal 10-to-1 resistor divider. Because of this, any resistance in series with VC will attenuate the control signal somewhat. If precise control of gain and attenuation is required, what are we doing here? What are we doing here? What are we doing? What are we doing here? Why am I reading this data sheet? What the like if precise control of attenuation is required, my brother in Christ, you're an attenuation chip. That's all you do. That's what you do. What do you mean in the case of? That if right there is just insulting me. Buffering the control voltage is suggested. Clip the Halls badge? What? Who? Huh? Oh, that. Okay. Oh yeah, look at that. He's got little lights there. Clip the Halls. What is that? That took me a minute. That took a minute for my brain to process. Sorry. What's going on here? Get me out of this window. No. I want to cancel this. I don't know how to cancel it. I'm trying to go back to chat. There we go. Yeah, it doesn't show the app. That's what confuses me the most. I wish... This isn't Chatterino. This is a social stream thingy-majig, and this is the reason that I'm able to put all the chats together. That's running on OBS as well. I guess I could run Chatterino separately, but it gets to be too much. 33 millivolt per dB control voltage law is essentially set by transistor physics and has the property of being proportional to absolute temperature. So now we're getting temperatures involved in this. Jesus, this is a mess. This is low enough to be important to be in most applications, but can reduce with external temperature-dependent networks. One example shown in Figure 2 with an inexpensive NTC. I don't think I can get a Vichy. DigiKey. It's going to be a DigiKey part. Oops. Oh, no, you keep using the Twitch system. That's on me. So this does not appear to come in any kind of a... What is it? What is this? 10K NTC. So I could probably get this in surface mount if I really wanted to. Yeah, as just the little NTC chip. And I could implement this circuit, which would, I could implement this circuit which would temperature compensate this thing, which is actually, hold on, where are we? Is actually a thing that I have to consider, because inside of a modular synthesizer, it's possible that there are temperature coefficients running about. The whole thing can get hot. I have seen big heat sinks on some of these modules. So if you park my module right up next to a one of these modules that requires heat sinks, we might run into an application where I actually have to do this type of thing in order to keep stability on the inputs. Or we could just say fuck it and just move on. We don't need to worry about this. It's funny, they put all this consideration into this. But then they say you might have to buffer the inputs. And it's like, I love op amps as much as anybody else, but I think this is getting a little bit insane. This is creating a virtual ground in order to single supply operation the thing. What other applications do you guys have? And I also think it's kind of scummy that they say our chip doesn't invert, but if you're going to get a voltage control signal out of it, that will be inverted. Like, that's a little bit. I have a 300 volt, 30 amp high power op amp. Can you like brick somebody in the head with it? Is it like that kind of equipment? 0 to 5 volt linear and exponential control optimized for modular synthesizers. Oh, hey, this paragraph. A 15 amp, 100 watt rail to rail amp. Holy shit, dude. The cool thing that I have, because, you know, EEs, we squirrel away. We squirrel away little things and sometimes big things, but you can see there on the left, not my insulin pump collection or the Macintosh in the background. That thing that's leaning up against my refrigerator right there is a 600 millimeter linear actuator. It's a 300 volt linear actuator that we've gotten working before. I bought the Granite Devices controller and we hooked it up and got it working, and it was able to push my fat ass 600 millimeters back without even breaking a sweat. I clamped it to the desk and we had it push me back, and it was, that thing could lift, it could bend my ass in half and it would crack. I would explode like a CD-ROM. If audio gear even thinks about making heat, put a sink and a fan on it, it'll end up in a hot environment anyway. The thing about modular synthesizers, you don't know where they're going. They could go in a cabinet that has plenty of backspace, but they could also go in a portable cabinet, which is fairly restrictive. And if it goes in that restrictive space with 10,000 other modules, you've got a bunch of these things generating all of this waste heat. And so you're going into a pretty spicy environment. So to be fair, in my final schematic, and I should make a note of this somewhere because I'm going to forget, I should probably temperature compensate this thing. My old hi-fi amp went pop from being under a shelf. Oh my God. And just the heat from being under a shelf. I actually, on the vacuum tube amplifier, the vacuum tubes have an innate heater that needs to run. And they've got really nice heaters. They run for about 365 days plus. It's like having a little lamp that's always on. But the problem is, Shit Audio designed this thing with tubes all the way down at the circuit board. And so the natural convection airflow is there, but the whole amplifier heats up quite a bit. So you put ceramic spacers on them. They sell these because this is a thing with vacuum tubes. You spacer the amps or the tubes, and now everything's lifted out of the enclosure just a little bit more, and they get much cooler. They're a consistent temperature. But I love tube tech. Yeah, I like how it's different physics are carrying your audio in. So the distortion qualities on the higher frequencies and on the louder stuff, it's just a little different. It's just a little different. I kind of like the way that it works for audio. I don't know. There's no other way for me to describe it other than warm. It'll warm up your loudness. If you turn the volume all the way up, it does not sound like you're getting harsher, louder audio. It sounds like you're getting closer to the source. The factory soldering was such a mess, I didn't dare fix it. My only problem with vacuum tubes is a lot of the vacuum tube stuff is very cheap now. And so I ran into a situation where I was plugging a tube into a socket and it broke the tube. And it broke the tube because the pin things weren't broken in. So you got to be really careful with the glass on the tubes. Kind of like the diodes. Reworking diodes before surface mount was such an obnoxious thing. So this is referencing specifically to modular synthesizers. Control input line 1, control input line 2. What the heck is going on with that? 0 to 5 volt linear and exponential control optimized for modular synthesizers. So this is like a signal path to VCA control port. 0 to 5 volts DC, and you're mixing them on your 100 PF. So they put a capacitor there instead. Power amp EVAL 117 and 118. I got them in a state. Ah, man, I gotta find more estate sales. I need more friends that are watching that kind of stuff, because the last one that came in was just a treasure trove of stuff to fool around with. Oh, so it's a big chunk. That's cool. All right, yeah, we're gonna be doing this stuff tomorrow, I guess. Temperature compensated exponential voltage to current converter. What the? What the? In 1999, Roman Sawa proposed using the. This is like, okay, so back in college, 1,000 years ago, we had one member of our team writing our report. I don't want them, no. I've had to say no to some stuff recently, just because things are piled on top of piles here. We had a rat in the house, and so we had to clean out the back area, and all of my stuff is now behind me, and it needs to be moved back in. I don't have space for stuff. It's very generous, Ryan Labs. And by the way, everybody here should check out Ryan Labs. Go check out Ryan Labs. If they're getting people in chat suggesting my chat, you guys should check out the other person. You definitely should. No, but I don't want them. I don't need 500 watt op amps to blow stuff up. It would be kind of funny to do like high current stuff and it'll explode and I get injured. I got to do some reading, it seems. I don't know if I'm going to get around to the reading tonight. There's a lot of little stuff going on here, but mostly these guys seem to have been centering in on temperature compensation in their amplifiers, which I think that's interesting. And we maybe need to think about putting these, what is this? Oh boy. Signal in, low pass filter, or low. Yeah, this is generic CV drivers. So they do buffer the inputs. Wait, oh, FC from the other. Two-pole resonant low-pass filter. What the? Interesting. That's cool. Okay, so this is essentially, what is it? Ripples. So this is where ripples came from, huh? Where's that? Yeah, this is essentially what ripples came from. Coherent generators. One that says that's annoying? What? It just says annoying? Look at that. So I did not know that we would find the whole circuit back again. This is one of those things where you have certain filter tunes and you run it through the amplifiers, and these are all controlled the same though. What's going on with that? Are we rippling back? I think we're just sending it through different filters. So 33, 33, 33, 220, 220, 220, 220, 1200, 1200. Okay, no, that's the same thing. Just different stages of that. I don't know. Weird. Pole state variable filter with resonance. Oh, that's the resonance then. Craziness. EE is not, it's not magic. These aren't runes. I'm not casting spells. Ah, that's cool, you poopsie doodle. Thank you. V Infinity CUI DC to DC converters. I'll send you some. All right, well, the way to do that is to get in touch with me on Discord. If you really want to send stuff. But I remember my sending policy is very, very important. My sending policy is that sending stuff to me is akin to throwing it out. You're taking extra steps to throw something out. By all means, if everybody's being nice and people are happy, oh, there's a link. Yeah, thank you. If everybody's, you know, nice and happy and honky-dory and we get along and all that stuff and I don't fucking hate you, I shouldn't talk like that. I will feature the thing on screen here. But, you know, there's a couple people with my address and every now and then something shows up and I can't guarantee that I get to the thing that shows up. Many, many years ago, I got a stuffed squirrel in the mail and I'm like, who, what? So I'm not popular enough to get a P.O. box yet. But I do know the CUI incorporated voltage thingies. That's, yeah, unless you have, yeah. I don't know. It's just, you know, the only other great shipping flub that I've had that I can remember is that I was supposed to get a bunch of Nylobones for Willow, and I got this $75 power supply, which was awesome. It's Amazon brand, but having the $75 power supply, of course, the best power supply goes to the scope, bar none, right? Your scope is your view into electrical engineering stuff. You don't want any noise to be present there. So the nice laptop charger goes to the scope. This thing has USB-C power. But then it also has another channel. So the other channel I have coming over here and going to our modular synthesizer stuff, because USB-C also has USB-C also has 15 volts. And $15, little man, is what we typically put into the Eurorack system. And then you make plus and minus 12 from that. So it's I think it's time to pack it up. Oh, the Rigol supplied a PSU, but I don't think it was cheap. Or sorry, I think it might have been a little cheap. The Rigol did supply a PSU, but it seemed to be kind of like cheap plastic and stuff. And this Amazon one, it's made out of metal, and it's got a little suction cup thing that goes around the outside. So when you plug it in on like a regular outlet, it can suction cup itself on so it doesn't fall out. It's so stupid. Okay, I'm done for the day. I'm done. I didn't set up the end card, but just so I can get all the links and information here. Our next stream is tomorrow. It's not 4 days ago. 10 days and 4 hours ago. No, I'm gonna be back. I'm gonna be back tomorrow. Don't believe his lies. Stability of gallium nitride by the powers of gallium nitride. Yeah, I'm gonna be back tomorrow. We're gonna work on this thing a little bit more. We're gonna try to suss out all this stuff while chat is irreverent, and we'll get there. But I will see you guys soon. Check out Flatulent Gonad. Check out the Ryan Labs, and I will see you guys then. Until then, I'm gonna go touch grass because apparently I'm the grass touching his streamer. It's like the ass touching his streamer, really, to be honest. What a place to be.